All right. Good morning, everybody. Welcome to Saturday in Hong Kong. What's Saturday? Oh, we can play on that laptop. No, that'd be a bad choice. See if wait for a few people to get in here. How are you? How are you today? Today's stream is gonna be about you, and it's gonna be about education and teaching you things. I'm not sure how possible education is. I mean, you really have to ask that question, right? Everyone thinks that, oh, we're gonna I don't know, maybe people don't even think this anymore. We're gonna really get answers to that question, though. One of the things I like to think about is AI, similar to God, is going to judge you. Like, I think about it, right? I'm applying right now for Hong Kong residency, and I have to put a resume together. And this is just like I gotta put a resume together. I gotta think, oh wow, remember that time I went to college and worked at Google and worked at Facebook and stuff? Oh wow, you got the normie, that guy, the interview coder guy, Roy Lee. I love watching the people this guy's destroying his future. Dude, what world do you live in? Oh no, he's rejecting stagnant tech companies and Columbia University. Wow. Oh no, he's destroying his future. What future are you talking about? My advice to him is make sure you're always punching up. You always got to make sure you're punching up, because once you start punching down, you don't have the people's mandate anymore. So I always try my life to punch up, and then once you get to the top, you gotta stop punching. Once you're the top, you gotta stop punching. You gotta be like, I'm the top. I don't punch anymore. We just try to build good things for many people. So. Oh yeah, no, oh my god, he's gonna be so he's gonna be so fine. What are you even talking about? Do you understand the normie person who graduates from Columbia and gets an interview at Amazon? I wouldn't hire them at TinyCorp or Comma. Probably, right? I wouldn't hire the statistical average of those people. I'm not sure I'd hire that guy either. I mean, to be honest, I don't think he wants to work at a company, right? I think that there's definitely some questions there. But no, I think if he really wanted to, I think he's definitely capable. There's just the type of person. I mean, I'm kind of like that type of person, right? Could I really work at a company? Yeah, I don't know. Maybe I'm unemployable. Guys, I'm unemployable. What am I gonna do? What am I gonna do? The system rejected me. What's happening with my utopia? I did work at Twitter. That's right. I was a 5-week intern at Twitter. My utopia? You mean China? I don't think it's a utopia. I don't think utopia is real. But I do think that, I saw, there was this guy, let me find it over here. Someone posted on Twitter that this is similar to my version of nobody profits. Chinese subsidies create, not destroy value. And it's pretty good. Do we really want tech billionaires, or do we want tech? In fact, megacap valuations indicate something's gone seriously awry. What China wants from BYD and Jinko Solar should be affordable EVs and solar panels. not trillion-dollar market cap stocks. Like, holy shit, yes. Yeah, like make cars. You know, they talk about the global south a lot. Yeah, you know, so I think that it's nice to see that I'm not like way off in the weeds thinking this stuff. And I read another thing last night. Maybe we can find it. It was on Hacker News. It was some like YIMBY crap, you know, like the, oh, we just need to build more housing kind of people. I don't know if we're gonna find it. No. Oh, here we go. Abundance isn't going to happen unless politicians are scared of the status quo. And there's a general fear of being a landlord. Tenants have a lot of legal rights, and the risk of inviting someone on your property who could start squatting or doing drugs and not being able to evict them is beyond the pale for most families. What the hell happened? Like, and then all these comments go on to talk about a legal balance between the landlord and the tenant. And something that I repeat all the time is that legal power is weak power. It's not strong. It's not strong power. You want strong power? A gun in your face is strong power. Saying, I'm going to take you to court, and then after paying lawyers millions of dollars and having a judge and a trial by my jury of peers in 3 years, I can finally get a settlement, which I then have to collect. Like, that's such weak power. So it's interesting that these things go back and forth, but that's the debate. And my argument is that the minute you framed the debate as a question of the legal rights of the tenant versus the legal rights of the landlord, you've already accepted that you're in a medium trust society. In a high trust society, these things aren't a problem. If someone starts squatting or doing drugs, their family will come and they'll be shamed, and you know you'll deal with this by like, why would you do that? You know, he's a good Christian boy and he goes to my church. And like, you can make fun of that stuff, but that is what it means to be in a high trust society. You know, I was thinking about Hong Kong is a high trust society. And I think that's one of the main things that I really like about being here. Because say there was like a typhoon and you know the bottom floor flooded. I would be more open to letting random Chinese people who live downstairs and don't speak English stay with us than I would if the same situation happened in San Diego. And it's sad that that's true, but it reflects the natures of the society. In fact, I'd probably let the person in San Diego stay too, but I'd be a little bit more on my guard. Okay, blah, 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 blah. Like, here, I don't really know how things are dealt with, but things just generally aren't problems. Maybe one of the reasons is, if you think about what the Christian morality says you should help the poor, you should help the beggar, help the person who's down on their luck, and it's good morality. But that morality assumes that that's a very small percentage of the people. Once that percentage of the people starts to become, these people are saying like 1 in 10 of your tenants is going to become a squatter. Holy shit, what a broken society. In Germany, tenants have more rights and legal protections than landlords. Again, you can. The minute you're arguing that, there's a thing that I'm in favor of, and that's the first thing that you think of. But then you realize the minute you're actually arguing that, you've lost the plot. You've accepted that you're not in a high trust society, because in a high trust society, these things just aren't that big of a problem. So that's the big question, and that's the big. I do think that to quote my blog post, the demoralization is just beginning in America, and it's that erosion of trust over the last 50 years. I wonder if there are polls on this, like USA poll: do people trust their neighbor? Okay, here. I mean, here's a proxy for it. It doesn't have to be a neighbor, but and again, I didn't plan this beforehand. Right? This is just my feeling, and then I Googled this. This is the closest question you can get at. Do you live in a high trust society or not? And you can see that even since the 70s, when I'd be curious to see this going back to the 50s and the 40s. Yeah, I mean, you can see the trend, and I'd also like to see that continue, and I suspect it continues on that same downwardly sloping line. It's not that I'm never going back to the US, I'm going back for the summer, but this is a major problem, and this is the root of all of these other problems, and it's so obvious living here. In America, I might, start on some dumb crap about how tenants have way too many rights, landlords should be able to immediately evict people if they don't pay. I agree with that. But again, as soon as you've gotten there, as soon as you've gotten to the point, I say the same thing about crypto. Crypto is the lowest trust society you could imagine. If society needs crypto, like the money, oh, well, we have a smart contract and we're enforcing this stuff, you're just in it's a backstop. Yeah, it can get worse. It can get, but in a high trust society, you don't need that kind of stuff. No, and it's interesting how it rubs off on me. How I find myself wanting to participate in society in a high trust way. And I think that this is a human universal. If you put people in a high trust society, put one individual in a high trust society, for the most part, they become more like their society. But unless this is fixed, it's over. Let's see if we can find the same thing for China. What? They're asking people in other countries about whether China respects the personal. What a joke. Into USA again. I mean, we'll speculate for a minute. Just imagine you were in the, right? Again, America's a medium trust society. I'm not worried in San Diego that all my neighbors are going to gang up on me and kill me because I'm a libertarian. I'm not a libertarian, but people have misconceptions. Whereas in Cultural Revolution China, that shit might have actually happened. So I imagine that when you compare China in the 40s and 50s to America in the 40s and 50s, well, America's way above China. But now it's changed. And if you haven't been to East Asia, if you haven't experienced this, yeah, I mean, I find that a lot of people in America are fed a lot of misinformation on this stuff. And until you fix this, you're never going to fix it. Oh, finally, we tweaked the law. We tweaked the law between the tenants and the landlord so there can finally be peace. Dude, that's a dweeb. I want to, this is like Dwight Schrute energy. You just, no, that's not how it's going to be fixed. Nothing's going to be fixed like that. And as long as people are thinking like that, YIMBY action, this doesn't work. Yeah, let's make everybody scared. That's what everybody needs. Yeah, let's make everybody scared. Yeah, okay. I think you all get what I'm saying. There's money and power and division. Yeah, you can argue that that's why this happened. But all right, welcome to the opening rant. And now we're going to go to subscribers only because now the opening rant is over because we are no longer in the opening. We are in the mid game. We're in the mid game. We developed our pieces nicely, got good control of the center, got a lot of squares covered that night. That night on F3 is looking real flexible right now. Coffee. We ran out of milk. We ran out of milk. Yeah, this is a good article. 5G here. I don't know what 5G is in America. I don't think it's that fast. So let's start with the basics of what a GPU is. Maybe we'll start with the NVIDIA CUDA. Have you guys ever programmed for a GPU before? We'll do it in Vim. So, have you guys ever programmed for a GPU before? Let's do a snap poll, and let's say, can we do a poll? Oh yeah, we got to do straw poll. I know how to do this now. All right, straw poll. Have you programmed a GPU at CUDA level? CUDA, HIP, OpenCL level. Yes, a lot. Yes, a little. No. All right. Let's see what we're starting with because this is a noob lesson. This is a noob lesson. We're gonna teach the noobs things, okay? All right. There's the link. Metal. It's all the same. It's all the same crap. Oh God. Oh God, really? Why do you even watch my streams? Why do we only have 214 viewers? We're weak on viewers today. Wow, wow, you guys. I don't know. Maybe all the pros are sleeping. Why don't I have any viewers right now? Why do I only have 214? Where's my viewers at? Okay. Friday night, late night, maybe? You know what I did last night? I played Magic the Gathering. Okay. All right, we're gonna have to start with some real noob shit then. GPU noob. Should we try to code in C? Does anyone want to code in C? Oh, let's code in Rust. Oh, yo, I never code in Rust. I'm so bad at Rust, you can all make fun of me because I'm terrible at Rust, okay? All right, let's see. Rust OpenCL. Let's see how to do this. A Rust implementation of the OpenCL 3. All right, how do I use Rust? Oh, I need an LLM. Oh, how am I going to get an LLM? This is so annoying. All right, well, we're stuck with this. Eventually, they're going to shut this down, and then we're not going to have any LLM anymore. Okay. How do I use OpenCL from Rust? All right, so we're gonna bring myself down to the noob level because I don't code in Rust and I don't know Rust, and we're gonna really start with some noob stuff. Okay. Create a pro queue. What? What? This is broken. Oh, this is the inside. This is the thinking. What? This is broken. To use, okay. We're gonna need a cargo.toml. Oh, it fixed itself, okay. All right, how do I init a Rust project? Creating a new project, okay. Cargo new GPU noob. Oh, people are gonna lose it because I'm writing Rust shit. All right, no, but let's not call it GPU noob. GPU noob will be the whole thing. We'll call it simple CL. Oh, that one created faster. Great. All right. Okay, we got a hello world. Okay, good. I like the minimalness of Rust. All right, so what do I do? Can I do cargo run? All right, sweet. Let's add a dependency. Ocle 19. Is this called Ocle? It's called OpenCL. It's built upon the CL crate. Is this really? Implementation of the OpenCL API. How do I know which one's more popular? Ocle is here. CL3 is here. What? That's CL3. All right, which one should I use? Do I want to use Ocle or OpenCL3? I'm going to make my image a little smaller so we can see more code. All right, so how do I judge what a good thing is? I don't know. 3 sounds better than not 3. Should I use Ocle or OpenCL3? There is a lower level binding. Beginner friendly. Oh, well, no, but then there's CL3, which builds on top of this. Oh. This is based upon the ProQ. You're new to OpenCL and Rust. Oh, I've heard about Rusticle. OpenCL implementation. Well, that's just not going to work. All right, let's just go with this one. Let's go with the OCL crate. All right, so we include the crate in my cargo.toml. Oh, look, I'm a Rust programmer. Do I have to use 4 spaces? Can I use 2? Just one of these languages. Oh, the standard. God. Fine. Connect, that's fine. Okay, good. Let's work. Okay, that's great. Okay, we got our nice code that we stole from an LLM, and it works. Remove that mute. Oh, I see why it thinks it's mutable. Okay, that's good. Great. Work size, global work size. What? Oh, I need some like Rust plugin or something. Why did all this crap show up? Oh, it's kind of heavyweight, but okay. What about locals? I don't love this. Let's read the docs. Which one did we use? We used OCL. Yeah, so it puts all the types in for me. Yeah, that's kind of cute. All right, can I see some examples of this? This might be too high level. I'm not sure what it's abstracted away. Dims. Does that work? No. Maybe extra argument. What's D? Spatial dims. All right, cool. That works. What about local ID? Okay. The global work size and the local work size might be set automatically. How do I override it? Set default local work size. Okay, cool. Read the data back. Yeah, that's great. So that's fine. big. Let's just change that to like 2v6, probably good. I don't like all this type stuff. How do I turn it off? Rust analyzer. Stop doing that. No, it keeps doing that. Okay, how do I turn that off? It is that. No, I don't want any of that crap. Oh. Okay, it's gone. Yeah, it's fine. But no! No, go away! Oh, fine. We'll have to figure out. Keep on hoping we'll eat cake by the ocean. No, it turned itself back on. A lot of assists. Okay. I want this off. Let's find settings. Is there settings? Settings? You guys get to see me be a noob. Is everyone excited about that? Rust settings, extensions, Rust analyzer. Here we go. Signature info, no typing. No. Okay, I can change the settings. Show syntax tree. Settings inlay hints. Off. Great. Oh, I see. So it is a global setting. Thank you. Thank you, chat. I figured you guys would know this kind of stuff. Great. All right. Let's go back in here. Cargo run. Okay, let's print these things out. God, how do I print in Rust? Print the output in the C loop. Thanks, LLM. Oh, that's not what I meant at all. That's not what I meant at all. All right, we should learn some Rust and how to print things. The positional arguments, got it. Okay, great. I'll format this a little bit nicer. 256 is a lot. I don't know, 128. Okay, getting an output from the kernel. This is kind of terrible. All right, first time I print this like that. That? Of course, that's wrong. You can pad numbers with extra zeros. Write justify with that. Okay, that's reasonable. And how do I print without the new line? Same as format with the text for the console. Okay, that's great. It's just like YOLO some Rust. Yo, boys, we have vibe coding. Does anyone like this vibe coding? Does that work? No, probably not. If I mod 16 0 who likes my vibe coding? Yo, we vibe coding. All right, great. You can probably go back to 256. 256 is probably a nice number. No, 128 is fine. Okay. Now we are, why is there a percent there? That's terrible. Y'all can make fun, you all can make fun of my bad Rust skills. It's not actually mutable because we don't change that, so that can go. Okay, let's talk a little bit about what this is doing. So you can get rid of that. We don't actually use those buffers. We don't actually use those buffers. Okay. So this is the source of the kernel that it's running in OpenCL. This is a magical method called getGlobalID. OpenCL is a little bit weird about this because it doesn't exactly you can think about GPUs really as, we're only going to use one global ID here and one local ID because that's all that there really are. So you can think about GPUs as G cores with L threads. So this is your, in OpenCL, this is called a group. This is called a local. In CUDA, they have different names. Let me just see this code in tinygrad. I forget what they all have like slightly different names for this crap, and it's like stupid. Tinygrad. No, in a new window, please. All right, so here's tinygrad. Look in C style and see what they each call them. So you see in OpenCL, they're called, so like the functions are like get group ID and get local ID. We'll get into what these are in a minute. So this is OpenCL. CUDA calls them the block IDX and the thread IDX. It's actually a much better name. What does HIP call them? Does HIP have a stupid name for them too? HIP calls them group and local. Same as CUDA, HIP. That's like the real HIP. What does Metal call them? Metal calls them thread group position in grid and thread position in thread group. Okay, but they're all basically the same thing. And you can think about it as 6 cores and so G cores and L threads. Okay, so I don't really know why this has a dim here. What happens if I get rid of that? What complains? ProQ has not any dimension specified. Okay, let's specify some dimensions. So here we should be able to say global work size. Actually, is it global work size? There's 3 dimensions, but you never have to worry about the 3. What? I specified the dimensions. Oh, stupid Rust. This is actually stupid OpenCL. We shouldn't blame Rust. It's not Rust's fault. Okay. So the stupidity of OpenCL is it specifies this thing called dims, and dims equals G times L. Okay? So in this example, G is 128. And then L is specified down here as 1. So if we want to see what those things actually are, we can go here and we can get the group ID of 0. And you'll see that right now we're running on 128 cores and 1 thread each core. So we can run on 128 cores, 1 thread each. Now if I change this local work size to be 2, how many cores and how many threads are we going to run? We're going to run 64 cores with 2 threads each. So let's see if we actually confirm that. We're setting the group ID there to the output C. So what we expect to see is 0, 0, 1, 1, 2, 2. But nope, that's not what we saw. Because for some reason, it didn't actually listen to this local work size. Ah, no, it's dumber than that. So you see what we did there? We didn't set the, let's make this get global ID 0 for the actual output of the thing. There you go. All right. So that's a global ID, and that's a group ID. So now we'll set it to the group ID. So your global ID is your you want to take your, so you can think about it as like G and L. You can think about it as G times num threads plus L. That's how it's actually stored. Okay. So now we can put it on 4 cores. Let's put it on 4 cores. 4 threads. So you see that's a thread. All right, we're good. Now if you see, I can do get local ID here. And we're going to see 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay, great. Cool. Is this making sense to everybody? Is this good? Is this good noob lesson? If I enable non-subscriber chat, are you guys gonna be terrible, or are you guys gonna be like, wow, he's actually educating us and teaching us something? Because we're gonna really, all these lessons build on each other. So I hope you're paying attention. You're like, oh, this is simple. Oh, I understand this. Okay, great, you understand this. That's great. Okay. Here's a question. What if I make dims really, really, really large? How does it run? The GPU doesn't have this many cores. If the GPU doesn't have this many cores, how is it going to run? And the answer is, think about the Gs. Each G is kind of like a packet of work. And it's, if you're familiar with like Grand Central Dispatch on Mac, it's like the same basic idea. All the GPU cores are sitting and waiting for a chunk of global data to become available, and then they'll run them on the threads. So let's get some real numbers here about how many cores GPUs have. So how many cores does a 4090 have? So NVIDIA calls their cores streaming multiprocessors. On NVIDIA, cores are SMs. On AMD, cores are compute units. Streaming multiprocessors. Compute units. My chat keeps breaking. I don't know why this breaks all the time. George looking like Steve Jobs today. Okay, now I think I'm caught up. Okay. Cores streaming multiprocessors. On AMD, cores are compute units. So let's get into some stuff. How many streaming multiprocessors does a 4090 have? That's a 3000. The actual name for the chip is 8102. There you go. Oh, that's pretty nice. $8102 right here. So each of these GPCs, 1, 2, 3, 4. Let's just check Wikipedia. So 8102 has 144 streaming multiprocessors. 4090. And actually, the 4090 might even scale that down a little bit. I think this is just the full chip. So 8102, 4090, let's do it nothing disabled, has 144 SMs, and it has this many CUDA cores. So remember, a CUDA core is like a thread. So there's 128 threads with 128 threads each. Well, I mean, this is education for everybody. So this is, I thought there was going to be 32, but maybe not. Okay, so then the 700 XTX is called Navi 31. So Navi 31 has 96 compute units. 96 CUs with how many threads each? I think it's this. Well, so the cool thing about this is there's actually a PDF that shows you what a compute unit actually is. That's a workgroup processor. Don't you love all these names? So each workgroup processor has 2 compute units. Then each compute unit looks like it has 64 threads. Now, maybe not. Actually, so a dual compute unit, 8 in each. 8 times 6 is 48, so it does have 96 compute units. That's a workgroup processor. And each workgroup processor has 3 SIMDs. So it does seem like they have 64 threads each. All right. This doesn't seem right because these chips do have similar power, but no, I mean, maybe that's right. Well, we'll dive in deep and we'll understand this. So yeah, each workgroup processor is these SIMDs are kind of like well, each of these SIMDs is 32 threads, and that introduces the next concept on a GPU, which is called a warp. Okay? GPUs have warps. Warps are groups of threads. And all modern GPUs have them as 32. Okay? So, are you guys familiar with what SIMD is? Put my camera to the left, please. Okay, who knows what SIMD is? Who can tell me? I don't know why this chat breaks. Is that live? The WebSocket gets disconnected or something? Okay, so SIMD stands for single instruction, multiple data. I don't know why chat's broken. Stream's working though, right? SIMD stands for single instruction, multiple data. So maybe a simpler way to think about SIMD is just to think in terms of vector registers. So if you think about a register on a GPU, let's say the register is 32 threads. Each thread can fit a single float. So if you have a, it's like a vector of like float 32. How many bits is that? Well, that's going to be 32 times 4 bytes times 8. So that's 1024 bits. And then if I do something like C equals A plus B, on vector registers, this is a single add instruction on 32 pieces of data. So the GPU programming model is slightly different from this. So if you ever use SIMD, this is how SIMD works. You can use this called like AVX or Neon or whatever you want to call it. GPUs use single instruction, multiple thread. The math is pretty similar, but on a GPU, you never see it do float 32. On a GPU, you'll just declare float. So notice how I just declared float here. So this is, or I can just declare int here, right? I can say like int a equals get global ID, and then a is here. So you don't see it, even though this is running on 4 threads. And let's increase it to the natural number of 32, so it's a single warp. So now it's running on a single warp, so there's going to be 4 warps there. Single instruction, multiple thread. So even though you don't see that this is a vector register, I just declared it as int, in reality it's a vector register. What makes SIMT a lot easier to program for than SIMD is loads and stores. Loads, stores are different. So the problem with SIMD is, let's say I want to get some data into A. If A is a 32-bit thing and I do A sub I, what that's going to do is load the contiguous 32 things. Load stores are implicit, scatter, gather. Because on a GPU, I've declared it like this, I can happily do something like that, and it will get them. Whereas on SIMD, it's explicit. That's it. That's the difference. GPUs like to hide this fact from you, that what they really are is 102.4-bit wide SIMD machines, but they really are 102.4-bit wide SIMD machines, but they have this special thing called memory coalescing. So you'll see that like GPUs can do all this stuff for you fast, even when accesses are not aligned. They'll do all of that for you. Okay, great. Does everyone understand the difference between SIMD and SIMT? You only declare float behind the scenes. It's float 32. Okay. So you might think like, why do I care? And for a program like this, the answer is you don't care. But let's see if we can get in a little bit and make the programs a little bit more complicated to the point that you might care. So let's put a loop in here. I'm gonna have to deal with timing shit in Rust. Perfect, yes. Ooh, that's pretty nice. Well, how did Rust know to format it like that? That's very fast. So let's add a stupid loop in here. We have to make it not get optimized out. The compilers are very clever. Also, this is kind of wrong here. We'll put it after the read. Let's make sure nothing's getting optimized out. Okay, maybe it's not getting optimized out. It's probably getting optimized out. Let's think of something that's too stupid to optimize. Okay, good. That didn't get optimized. Wow, it doesn't know how to multiply by 2. Okay, great. So that takes 37 milliseconds here. That's probably good. Okay, 163. Okay, so what's going to happen if I only run this on one thread? Takes the same amount of time. No idea why that is. Probably because globals isn't big enough. I'm going to have to make globals bigger. CNC data. This stuff isn't used anymore. Not used, not used. Let's make dims. Find a number that matters. 32768. Actually, that's still too small. Oh yeah, all right, that's chilling. That's chilling. All right, 2 seconds. Oh, faster. All right, 220 milliseconds, great. So now, if I only tell it to run on one thread, yeah, should be about 32 times slower. So is that 32? It's 229 times 32. Yeah, okay. It's about 32 times slower. Okay, now if I run it on 2 threads, twice as fast, right? This makes sense? So remember that this is not going to be your global threads. This gets divided by this. So like, how many threads are we putting it on? Go to 4 threads. Faster. 8 threads. I also want to time this. I also want to change my timing a little bit. I don't want to include the read in the timing. So I should be able to do something like proq.finish. Yeah. And we'll do timing there. This result may be an error variant. Okay, great. So 8, 16, we'll watch it still get twice as fast. Should be about 420 milliseconds. 32. But something interesting should happen at 64. At 64, I predict it will no longer get any faster. Yes. Does everyone understand why? They tell you this stuff about how these things have multiple threads, but I never think about it like that. We'll get to, well, I don't really understand why that is, but you can really think about GPUs operating 32 wide. Oh, I know why. Never mind. I understand why. Okay. You can think about all GPUs operating basically. GPUs are multi-core processors with 32 threads. So we're on a Mac. Let's actually figure out what we can do. There's a lot less publicly known about this stuff, but you see why putting it to 64 there no longer made it any faster? Because GPUs only have 32 threads. So what you're doing if you're going to 64 is you're going to run this chunk and then you're going to run this chunk. It's just what happens. So if I go to 16, and then I think 128 is not going to give us any more speed either. And then eventually, let's keep going up here. 256. Let's go to 512. 512 doesn't work. 256 is max threads. Now, if you're like, oh, they're running sequentially, oh, why does it even matter if it's, well, actually, is 256 the max? Let's try 27. Okay, no. Good. We have like some plausible numbers here to work with. Okay, so let's see what we can find out about Apple GPUs. M3 Max GPU. So it's a 40-core GPU. But these cores can do a lot more. try to figure this out by profiling if we don't have another way to get it. Okay, here we go. So the M3 Max, I have the big M3 Max variant. It has six execution units, I assume that stands for. Yes, execution units. Execution units. And then it has this many threads. Let's see how many they're saying is per. 8? That doesn't make sense. It doesn't make that much sense. But okay, I think we can figure this out. If we can figure out when it stops. We can change the global size here and figure out when it stops getting faster. So this says there's, let's just try that to start with. So I set the local size to 32. So that's going to put it on 320 cores. I don't think execution units are exactly cores, so we'll figure this out. Okay. So that's 320 cores. How much slower is it when I go to 600? Oh God, it's a little slower. It tells me nothing. Let's start with 1. That's fine. So 1 takes 36 milliseconds. So 36 milliseconds is my minimum. 36 milliseconds. This kernel takes 36 milliseconds to execute. So think about it. You got threads. Actually, let's just go to 1 here. Oh, well, that didn't work because the workgroup size, yeah. Set that to 1 as well. Okay. So this kernel takes 31 milliseconds to execute. That's just it. Takes 31 milliseconds to run this stupid loop. We can try to figure out why that is in a minute, but well, let's see if that's remotely plausible. Okay, so it's 1,000. So 26. It's that like doesn't seem that plausible. This GPU is like slow. It only needs 1 million. This thing should be running at gigahertz. I don't understand why that's so slow. Oh, there's like a base, I see. Okay. Yeah, it's not that great. There's like a base thing that's just oh well, you know what? Here's something we can do. Let's not look at the first run of it. Run it a few times. I write a for loop in Rust for warm up in like that. Oh, okay. Well, it's just slow, it's fine. No, let's just do it. we can get that one. It says 32. Okay, 14 milliseconds there. Yeah, okay, good. Now we're seeing good scaling. So it's 14 milliseconds to run. The first one's just slower. But now you see when I add one more zero, it adds one more zero to the thing. So the kernel takes 15 milliseconds to execute. That's 1 E6 its in 15 ms. So let's find something. 126. So that's something like 66 million per second. What's the clock speed of the GPU? Boost up to 1600. Something like 24 instructions. Cycles per. Okay. Seems somewhat plausible. Cool. Okay, so one of these runs in 15 milliseconds if we do a global size of 1. Oh, that's going to be really slow. Okay, so 256 didn't get any slower, which means that the GPU has 256 cores. Remember, GPUs have cores and threads. So it's easier if you just like look at one. I found this thing high yield. This guy that goes into the chip, it's cool. So it's helpful. Like everyone needs to really
44% of the entire chip. The compute parts.
Everyone needs to really understand what's going on here before we can move on. All right, so this is the chip. Each of these compute units is a core. And then inside the compute unit, we can zoom in and we get a thread. So in each of these cores, each of these threads is 32. So each of these is like a little computer with 32 threads. See how everything's 32? So each of these compute unit pairs has like 4 cores inside of it, and those are full cores. So that's 8 times 6 is 48, is 109 times 4 again is 192. So there's 192 cores, each with 32 threads. So 256 is still fast. Let's find when this starts to slow down, and we can figure out how many cores this thing has. Okay, so that slowed it down. That takes twice as long. That means it's taking like, some cores have to run 2. So let's see if it's really 640. 640 is a little slow. 600 is a little slow. That's still fast. 513. 513 is fine. 520. You know, I used to say hacking is just binary searching by hand. 540. 50. Ah, that got slower. Should we like make plots and shit? We should make plots. Who's ready to make plots? Well, let's make plots. God. All right. You guys are really testing my Rust skills here. Should we use Rust to make the plots? I don't even know how to write a for loop in Rust. For num cores in. Now remember, this here is fixing it to be only on one thread. Where do I set the dims? Wow, I set the dims all the way there. Can I change the dims? I want to update the dims. Yeah, there we go. Myat. Data length exceeds buffer length. What? Wait, what? Where does it tell the size of the buffer? The default dimensions will be used? Oh, no, not cool. Not cool, bro. Why would, what? That doesn't even make sense. Buffer builder? Doesn't even make any sense. Why would you use that? Well, I'm going to make me buffer, not shit. All right, here we go. Okay, here we go. Buffer builder. All right, let C buffer equals. Did I have to import the freaking buffer? Buffer builder Q flags len build question mark. Oh, wait, what is the question mark though? I think I just want to use that question mark in some places. Why did you ignore that? Okay, good. Great. Thank you. That don't make sense. Oh, I broke it. Oh, no, I didn't break it. Oh, I see. It just multiplies 0 by 0 a lot of times. All right, so how do I like lie to this and get it to like not? Oh. Okay. There you go. Yeah, I used it. You see, I used it. Yeah, it's legit. All right, cool. Myat. 32. No, but didn't listen. Oh, bitches don't listen. Oh, I know what I can do. Oh, I just didn't do that earlier. The dims don't really matter. There we go, okay. Now it's only running at 32. Great. All right. For test cores in 0.124. Does that work? Cool. All right, so we're going to see a jump when we get to the number of cores. All right, we're going to make a graph. Can you make graph in Rust? Is that doable? We can also, how do I like? All right. Step in Rust loop. Step in Rust loop. Oh, step by. Now, how do I make graph? Graph, range step inclusive. Yeah, good. They got rid of inclusive. That's good. That's good. Rust is moving in the right direction. All right. Make graph in Rust. I don't know why the chat keeps disconnecting me. Yeah, you like my new lesson? Is everyone happy? I'm teaching you something, hopefully. You guys never coded on a GPU before. All right. Ooh, bitmap backend. Using the pet graph. Recommended. No, I want a chart. Use plotters. Plotters. Is this good? Let's try plotters. Plotters. Oh god, I need to make an array. I'm gonna do this. Guys, Rust is impossible. And can I put the question mark there? I want to bang there. Can I bang? No, question mark. Can I question mark? Can I make you happy, Rust? Rust is never happy. Oh good, we can remove that myot. Don't myot. All right. Bitch, I want to plot. How do I make a vec? V. Yeah, V, that's a good name for a vec. V dot. No, don't put it in a box. Oh, do I need to tell it what it's a vec of? What's this a vec of? Man, I wish I had like the type hints would show up. You know? Why does my chat not work anymore? What? No, I hate this. Why is it doing that? Why can't I make a vec? Make that vec, but I can append to it with tuples. The plotters. Yes. Oh, yes. Oh, immutable vec I32. Except no, I want float. F32? Oh, yeah. Let myot points equals vec new. Yeah, there we go. Yeah, push those points. Yeah, now we're talking. Oh, man. I'm a Rust programmer. All right. It's like the LLM's a Rust programmer. I'm just here to criticize it. Why do I want awkle error? Why is it? Oh, fine. Yeah, you got a box? You happy? There's a box. I bought you a box. Oh. No, don't do that. That good? Do I have to import block? Hey, yo, I'm getting errors. Yo, I'm getting errors. Yeah, please, don't fix them. Yeah, we're vibe coding, guys. We're vibe coding. All right? Yeah, you did a bad job, so you gotta parse all that crap. Oh yeah, okay. Well, the user's main function returns result. Oh, maybe it should return result, comma, awkle error. Oh, great. Yeah, but what? No. You're using generic error. Yeah, that's right. Yeah. I got a box. All right, good. I'll put it in a box. All right, is that good? Is everybody happy now? I'll put the error in a box. All right, is that good? No. Oh, Rusty explain. All right, yeah. Oh no, not good. No. Why is it still trying to do awkle error? Let's import that one first. Yeah, that work? No. Yeah, that's right. Great. They have an alias? No, I don't have any alias. I put the error in a box. Who knows what I did? Oh, result. Oh, I see. What a scam. Oh, huge scam. Okay. Why do you keep using result? No result, just error. Results imported. What? Some crap. Expected duration found I32. Oh. Well, we're not going to sit here and wait for that every time. Yeah. So elapse, unfortunately, is a duration. If I go like to float. What's so good? As millis. A millia here, a millia there. That error is backwards. U238, okay, as I32. Okay, just draw my plot. Oh yeah, look at that piece of shit plot. Yeah, that's exactly what I wanted. Yeah, wow, you really read my mind, Rust. Actually, kind of like Rust. No, why can't I put that in there? Oh. No. Don't forget your those things. 14, but no. Come on, I want like a float. No, come on. I want like a float. No, don't do me like this. Come on. All right, fine. That's good. That's good. All right. You happy? Good. Everyone's happy. All right. So where my plot at? All right. Well. So what's the plot? Oh, did I not like? Did I gotta like tell it to like actually do something? Did I not copy and paste something? User collected points. What? Like save it? There's no line in the pinch. How I get line? Vibe coding. I love LLMs. Oh, is this the problem? Oh, that's the problem, maybe. Why would it ever do that? Oh, the range. Oh, okay. Thanks, thingy. I don't know. Let's go to like 100,000 here. And we'll go to like, I don't know, 124 here. Ooh, yeah, baseline plot. All right. 100,000 might be a little overkill. Let's go to 50,000. And let's go to 124 here. Yeah. Oh, check out baseline plot now. Yeah, all right. Does everyone understand how many cores it has? I don't really understand why it's doing that. But we see a hard changeover at 640, I think. So there are 640 cores, and then the scheduler is just like kind of mediocre. All right, what's margin? What's this? Size of the four margins of the chart. Why are there so many lines? All right, but so it is 640 where it hard switches. No, it's not 640. Oh, yeah, it is. Okay, good. So it does have 640 cores. Okay, good. Everybody's happy. Just the scheduler is kind of shitty. So it really does have 640 cores. I don't know why it only has that many ALUs. Now I expect can I do like this? Of course that's not going to work. Array syntax. Cannot use points in this scope. That's actually a reasonable error. Orange is not a color. Yellow. Yellow is a color. Yellow. No semicolon. Parentheses? You be happy now? Good, you be happy. Good. Everybody's happy. Oh. Whatever, we can start at 64. All right, so now we're just... What? Why is that invalid workgroup size? That don't make sense. Oh, because it's not like a multiple. That shouldn't really be required, but whatever. Quick fix. Yeah. Should actually want max. Yeah, look at that. Yeah, we did, you know, it's gonna be man. You imported min and you didn't use it. Okay? I went to all that effort to import min for you and you didn't even use it. Yeah, okay, baseline plot. All right, well, that's what happens when you put in threads. I don't know, let's go to 2 there. Let's make that a little faster. Well, if that's 640, that's a divisible by 16, so that's good. Let's go a little bigger here. Oh no, no, we made a mistake. We made a terrible mistake. That. The chart's mad impressive? Yeah, right? Don't you love Rust? Rust's kind of great. Is Rust going to be like my new thing? Ugh. It's the ugliest yellow I've ever seen. Cyan. Oh, no. Magenta. Magenta has the perfect color. All right. I don't know. Let's try times locals there. No, that's not really what I want. Let's just step by 64. And let's go to something crazy there. Okay. So if we have 640 threads, 32. Oh, it's looking slow already. Look at how slow it looks. Oh, it's gruelingly slow. Oh. Oh. I'm not going to sit here and wait while that happens. What? What? Come on. Be happy. Okay. All right, so yeah, this is kind of, notice how beyond here it doesn't matter anymore, because this is how many threads the GPU really has. So measured. We measured 640 EUs and with 32 threads each. We can add some more colors in here. I don't know. Actually, you know what? Could we just make them all the same color? I'll loop them. Does everyone have a good understanding of what this is going to look like? So you can see, should actually do ×2 times locals with a min. I need min. Oh, let me just import min. If it tells me that I could put the comps together, no, it didn't tell me that. All right, so does this make sense? That's with one thread, 2, 4, 8, 16. But then 32 and 64 are the same because there really only are 32 threads on the GPU. So all it can do is run this thing twice. Doesn't make sense to you? Yes, all right, you get it now. That's good, that's good. Great. So this is the minimum amount of time that this kernel can take. That's just this kernel. If you just run this kernel single-threaded on one thing. And then there's a question of how many threads you want to run it on and how many cores you want to run it on. So it'll dispatch to all the cores, and this means it has to run in series. So this means it has to run serially, so it has to run it twice. All right. Does everyone understand baseline plot? Because we're gonna get rid of baseline plot in a minute. Let's actually commit this stuff. Might be useful for somebody. No commits yet? What? Oh, is this something like Rust? Rust automatically creates a git shit for me? I don't know how I feel about that. I really don't know how I feel about that. That's a little upsetting to me. Did it name it main? If it named it main, I'm gonna lose it. Oh, good, it named it master. All right, we're good, we're good. Everything's fine in the world. Those look like good files. All right, let me create a thing for you quickly. Because we can also start to run this on tinyboxes. If we want. All right, noob lessons from stream about how GPUs work. Let's add a remote and let's push that shit. Oh no, come on. Yay. All right, you guys can go to the repo now. Okay, so we made baseline plot. Everybody understands it, and we're good. What else do we want to check? I mean, I think this kind of explains the GPU execution model to everybody. I don't know why it says that that's the number I'll use. That is only 500 and doesn't seem right. Apple calls a GPU core seems to be the same as what NVIDIA calls an SM. Each core it's interesting. I don't really understand. It's mad because it moved. It's fine. All right. Let's let non-subscribers talk for a little bit. Let's talk about what we don't understand about GPUs, okay? Only serious questions. The ban hammer is gonna go hard. I think that like my chat's broken. You're asking me to ban you? Okay, done. How they settle on 32? I don't know. NVIDIA did 32 and everyone just kind of copied them. Is this Rust code vectorized? So this chunk here is what's running, is what's being dispatched to all the GPU execution units. So you can see that the dispatch happens here, and then I wait for them all to finish here. And then, like, hopefully you understood what I said about the course and the threads and stuff. Time zone am I in? I live in Hong Kong. Yeah, GWell sort of. So I think we talked about that. It's not really SIMD, so it's SIMT. So the GPU that I'm working with here is basically 640 cores with 32 threads each. It's a little bit more complicated than that, but does AMD still have 32 and 64 thread modes? It actually does, and that came up this morning. There I said, so AMD has the best documentation for like all this stuff. And they'll talk about, so AMD doesn't call them warps, they call them waves, okay? Waves. So you can get 32 and 64, but all the code I've seen only outputs 32, but there's apparently something outputting 64 now. Good website to understand GPU nomenclature. Let's see what we got. Am I still holding AMD stock? Yeah, I'm holding for a long time. Oh, interesting. Who's modal? Why is it green? program GPUs. Yeah, okay, cool. Well, it's pretty good. Yeah, this is good. Good call. Yeah, so I mean, then we can get into like latency hiding and how that stuff works. If you think about a CPU will context switch in order to hide latency from like a network card or a disk. A GPU will context switch in order to hide latency from memory. Google's over. Google's dead. So I've been working a lot on the DSP, on this DSP, on the Qualcomm DSP. So I've been reading this manual a lot. You get into like how the DSP works, and the DSP is a SIMD machine, not a SIMT machine. So all the memory accesses are annoying, and then there's like very specific patterns you have to use it in to be fast. But you can see the Qualcomm hardware channel. I've been posting all the updates. We've finally been making it like fast. And then comma can switch back to the DSP for the driver monitoring model. But yeah, like when you look at these, like look at that instruction. Like look at what that's doing. So it's doing a here we can see the vectorized version down a bit further too. So like this is the vectorized version of that. So you can see it's doing, and this is not the whole thing. So it's actually 128 bytes, which is 124 bits. It's the same, 1024 bits. It's the same width as a GPU. And then this is a MULAC, but it's also a 4-wide reduction. And it does this because these are int 8s and it wants to accumulate into a 32-bit. So if you want to keep the input and output registers the same, you have to think of the data flow in your chip. So I think that, can you implement efficient flash attention in the Qualcomm DSP? Yes, you could. Isn't this under NDA? No, this is publicly available. You have 2 job offers, one from the AMD Linux kernel team and Google network engineer. Are you a good programmer? If you're a bad programmer, stop fucking up the AMD Linux kernel. But if you're a good programmer, by all means, why would you go to Google? AMD has a future, Google does not. AMD has a serious future. I know the stock dipped a little bit, but we went up, we went down. I'm in AMD for years, guys. I'm not. Lisa Su DM'd me on Twitter and sent me $500,000 worth of hardware. This is a company with a future. I don't know how the stock market's going to reflect it. Fuck the stock market. Who cares? I know that this company is going to deliver increasing quality AI hardware. You're one of the good ones? Great. So it doesn't even matter. You know, I remember when I lost money on Meta, which if I just held my Meta, I would have lost money. But like it's like this shit doesn't. And I think that's what we talked about at the beginning of the stream. This shit doesn't matter about, just deliver value. Everything's different right now. Just AMD, yeah, whatever. Market specific risk, corporate specific risk. Who cares? I think in 5 years, AMD will have a larger market share of GPU compute than they do right now. What GPU are thinking for the external enclosure? Probably like a 7600. The problem with the 7900, so it's got to be an RDNA 3 GPU. So all our USB stuff only supports RDNA 3. I mean, we can add support for others, but so the problem with the bigger chips is a power draw. So it's going to be just hard to get that amount of power in a car. Your cigarette lighter is only like, if you have the old school cigarette lighter thing, that's only 10 amps. So realistically, you can only probably get like, so 10 amps is 120 watts max, but you could probably only get 80% of that. So it's really probably only gonna be like 100 watts you can get. So even a 7600 has a higher TDP than what you can easily pull from a car. I bought one of these in China. That's about what I paid for it. Yeah, that's all right. What number formats are going to win? I don't know about that. I think that it's been a slow. I think that we're going to increasingly move to FP8. I think training and things below, even FP8's annoying. Like BF16 is what you can get away with without being annoying. But no, I do think it's going to be some kind of 8-bit number. I think 4-bit's too small. You can look at the quantizations. So you can look at the quantizations of LLMs. You can go from 16 to 8 basically for free. The 8-bit ones perform almost as well as the 16s, but I've never seen a 4-bit one that performs as well as a... What's going on? Is there fire? We got all the fire trucks going by. What about the modded 4090s? I mean, they're modded 4090s with more RAM, but they don't increase the RAM bandwidth. All these people on Twitter who like circle jerk about like it has 128 gigabytes of RAM. Yeah, but if you only have like a RAM bandwidth of 400 gigabytes a second, well, you can only read all that RAM like 3.5 times per second. Oh my God, none of those things remotely compete with NVIDIA, with the tinybox. The little shits, the little $3,000 shits, they don't remotely compete. It's not crime, it's the fire department. HVM, yeah, I've seen that guy on Twitter. I don't really understand what it is. Your order virtual machine is a massively... He talks about it like it's the best thing in the world. I don't understand that. I have no idea what the hell that says. Right? Like compare that to the tinygrad README. It's like, oh. Like, okay, create a thing. Interesting. And then like, all right, we have like a very normal looking example here. Like anyone who's ever read Torch can like immediately see that. And then like, oh, a link to an example. Okay, let's see it. Oh, wow, that's actually really short. That's a cool MNIST thing. All right, so I like to find my layers, sequential. All right, like, yeah. I don't really understand what it is. It might be cool, but like the question that I ask is like, what can this do for me? Paper. All right, so I'm going to read a few papers. I think that's going to be the second part of this stream. I'm going to go downstairs, get a tea. Yeah. Okay, so these are their like basic ops. It's kind of like an even smaller than like tinygrad has ops. They're called UOps. So here's the offset for tinygrad. It's getting a little big now, but like, seeing it like, these are pretty simple. And this is a global offset across all the different transformations of the IR. So like MLIR lets you define custom offsets and custom areas, which like you can argue is better, but I don't know. I try to keep it simple. Like if you can just like have them all, whatever. I have the same philosophy in like if it's serial in Ombot. So okay, they have less. Erase is a binary, no. What? I don't understand this. Yeah, Bend is the human readable language. Okay. I see. And I've seen like this looks very Haskell, right? Like you can do this kind of stuff. But yeah, I don't know. Like tinygrad would just take that sum and turn it automatically into the number. This is some functional programming BS. Like I kind of agree. They don't. What I found with so many functional programming things, like with Haskell, and they want to be esoteric. They want so badly to tie it to math and to sit around and circle jerk about math all day that they have some legitimately awesome ideas, right? Like pure functional is great. The idea of lazy evaluation is great. Like tinygrad takes all of these ideas. They're great ideas. But then like, oh, well, you're going to use a functor combinator to curry over the monad. Okay, what the hell is that shit? We're going to do a map over the shit from that shit to that shit applying F. Great, love it. But that's never what they do. They're currying a monad. We got salmon and tea. HTTP is port 80. What? Okay. Let's go back to subscriber only and let's read some papers. So this paper just came out, analyzing modern NVIDIA GPU cores, and we're going to read it together. There is no papers that talk about how to do that have a modern understanding of GPU microarchitecture. Describe the operation of the issue stage. So these are stages in the pipeline. I don't know what those are. Apparently this is good. A simulator that's 14% inaccurate. Stream buffer. So the register file cache and number of register file read ports effect. That's crazy to me that the register file has a cache. Processing blocks. This is some old shit. This is the old one that they used in 2006. Okay, our approach is based on writing a bunch of small micro benchmarks that consist of few instructions to measure the execution time. So NVIDIA GPUs have CUDA PTX, but then PTX is not actually what runs on the GPU. So one cool thing about AMD is that RDNA is actually what runs on the GPU. So the RDNA instructions are actually the machine code. But in NVIDIA, you have to go to SAS. How great is this CUDA assembler thing? There's another thing that's just way better about AMD. Oh, by the way, UUVN got the AMD backend working. on this computer. 300 teraflops. So this is running on a Me 300X. And then we can do like beautiful MNIST multi-GPU, which is TinyGrad's simple multi-GPU implementation. You see it's going on :1. There you go. The sync is still slow because we're using PM4, not AQL. So once we have this upstreamed, we're going to need to find a better way to... I'm going over this a little in the other stream. But the MI300X is actually... the best way to really think about it, this is a picture I want. The best way to really think about it is as so hopefully everyone understands that kind of stuff and what we've been talking about today. They even add a layer on top of that. So a single MI300X is basically 8 completely separate GPUs. So that's a GPU, that's a GPU, right? 1, 2, 3, 4, 5, 6, 7, 8. So when you have a computer with 8 of them, it's basically a computer with 64 GPUs. These are unique GPUs that each schedule their own like warps to them and stuff. They have their own scheduler, they have their own firmware. Everything about them is very, the only thing they share is this high bandwidth memory link. So the difference between 6 discrete GPUs or 8 discrete GPUs and this is that the bandwidth here, the interconnect bandwidth exceeds the memory bandwidth. If your interconnect bandwidth exceeds your memory bandwidth, you can basically treat it like one GPU. I mean, that's interesting. It's so much more complicated than AMD. Okay, so firstly we describe which warps are candidates for issue. So the warp, remember, is a 32 wide thing. And then there's like that's a 32 wide, like there's 32 threads. And then that thread group gets assigned to a core. Warp is considered a candidate for instruction. A valid instruction in the instruction buffer. So let's understand this a little bit. SIMs have 4 different subcores, and warps are evenly distributed among subcores in a round-robin manner. Wait, what? $65,000 registers? Oh, I see. So there's 2,048 warp registers, I see. So AMD does this a little bit differently. AMD has 2 types of registers. They have VGPRs and SGPRs. Yeah, so there's I think 255 VGPRs or something. Yeah, 256 VGPRs. And then when you allocate them, you can your number of warp the number of I don't know, GPUs are so complicated. Number of warps you can have in flight. So each warp has 64 private. Okay, so these are basically the scalar registers. Predicate registers. So this has predicate registers too. What does it talk about them? Stuff. What is HS and GS? I don't even know if it has explicit predicate registers. Okay. So this has explicit predicate registers, uniform predicate registers. Okay, so they're uniform. And AMD calls them scalar, and NVIDIA calls them uniform. Like previous works, that includes the presence of an operand collector. There's a dedicated write port of 1,024 bits. Remember, that's the width of the SIMT. The hardware structure responsible for efficiently gathering and managing the operands required by instructions before they're executed by a processor's functional unit. Okay, I see. So basically they're saying instead of having something to do this, they just, like, they have all these control bits, which do it basically statically in the compiler. Now I'm going to read policy that matches all the cases we've studied. Only used by instructions that have operands in the register regular file. Wow. So, I mean, the reason that you want to have a simulator is because you want to be able to perfectly predict your performance so that you can make better choices. warps per SM? What? Oh, that's warps per SM. Okay, that's a total warp. I see. So that warp per SM effectively is that thing that we were looking at. The Apple thing has 16 warps per SM. Wait, what? Remember when I put a note there? What happened to that note? Must have gotten deleted. Okay, but still, 640 divided by 40, 16. So it has 16 warps per SM in Apple. Cool paper. Here's the people who did this for an RDNA GPU. They did some weird stuff in GCN with like stuff being like 4 wide. I don't know. I'm not going to waste my time learning how GCN works. But yeah, so this is the RDNA 3. We have the vector registers, the scalar registers, scalar ALU, 20 wave instruction buff. Interesting. So this is a look ahead buffer basically? It's like a reorder buffer? So what a reorder buffer is when you think about like the, so I think a fun project might be, and something that I might get interested in, maybe next year, might not be this year. So this year is the year of speed. We're working right now on MLPerf-BERT. MLPerf-BERT is, we're doing like, I think now we're up to like 60% better. So like 40% of the time is gone. From what it was before. So it's 60% of the time it used to be. So yeah, this year we're still focused on a lot of high-level stuff to get speed. We're working on adding local memory support. So there's memory in each of these things. This VEC, well, it's VEC memory, but it's called share memory. It's local to each compute unit, and you can only access it from your locals. So that's something that we're not supporting in tinygrad that we can make things faster with. But we're almost done wrapping up a contract of getting tinygrad to be fast on the Qualcomm DSP. The Qualcomm DSP is the simplest chip. These things are so complicated compared to the Qualcomm DSP. Like the Qualcomm DSP has a instruction packet where you can pack 4 instructions in. I don't think it has anything like this. I think you have to do this like explicitly at compile time. The Google TPU is also very simple. So I don't know if you guys read my blog post where I talk about the tragic case of Intel AI. But there's like programmability is on a spectrum. And what I mean by programmability is like it's simple to code for to get performance. So CPUs are really easy to code for to get performance. Like you barely even have to think about it. You're not going to get that. Like you're gonna like it's really easy to. I shouldn't say get performance. I should say saturate the max performance of the device. So it's really easy to get the max performance out of a CPU. GPUs you can kind of get the max performance out of. Qualcomm DSP and Google TPU require really fancy compilers, memory layouts, all of this stuff. To then like Gaudi and the Apple A&E are like, they're not even the hardest to get performance out of, but if you have a program that's like, oh, I have like a 4x4 convolution with stride 3, oh sorry, this thing doesn't support that. Like it's just a fixed function unit. So it's really easy to get performance for like a gem, but the minute you step it all off the beaten path, you can't get any performance. But I think a fun project might be to write a simulator for the Qualcomm DSP and truly understand everything this chip is doing. So these GPU simulators don't look like they're ever perfect, but for this one, it might be possible to write a perfect simulator for. I think it would be a lot of fun. And then once we have a perfect simulator, we can figure out how, like, if I could take that simulator logic and then put it in a constraint solver like Z3, that's what I'm really interested in doing. Well, again, there's chats and they don't show up. I don't get it. But yeah, no, if you could put all of this stuff into a constraint solver and then say find the fastest program to actually compute this. The Akita simulation engine. This stuff open source. And did these people open source their stuff for this? No. Subprojects. MGPU sim. No, it's GCN3. What level does the NVIDIA simulation run at? Ooh, separate AMD and NVIDIA folder second try. Okay. Not ready for use. GCN3. So they never upstreamed this. It does look like it's still being actively developed, which is cool. But we reuse a few components, most of the NaviSim simulator. Is this open source? I tried looking for it briefly and couldn't find it. Who wrote this? Oh, we should also read this. This is a 2022 paper. Maybe they talk about why they open source it or don't open source it. Oh, NaviSim is open source under the terms of the MIT license. Oh, it is open source. Where is it? Link hidden for double-blind review. Oh. Who could find it? It'd actually be cool to try to get this to run. No publicly available. What? GPU sim is old. Maybe I can find them. Maybe they filed issues or something. Is this what I'm looking for? Maybe. Oh, it's on GitLab. I see. Cool. Good work. I think that's it. Ish. Why does it even work? All right, last update 3 years ago. Good find. Thank you. I wonder how fast it is. No, who thinks it builds? Well, that's a quality file. New GPU. Package navisim. Who's a CUDA? Are these people a CUDA? Do you even read? Second guy who sent a link. Thank you for subscribing, but please read what you just sent. So weird. It's not even inactive maybe. Wow, it's really deeply hidden in there. Well, Akita's the simulator, but I didn't realize the simulator people were doing this. I didn't realize it was the same group. All right, so like, what can I like do? Like, what if I do like go test? Does that work? All right, go find and connect to the internet. Sure. We'll install the Go team at Google. Do I trust them? What are you trying to sell me an ad for? All right, well, it doesn't have tests. Okay, so you go to all this effort to write this simulator, and then that's your README. Was there another repo? Is there another repo I'm supposed to be looking at? This is their old one. You trust them? Well, what? All right. Compile the simulator with the benchmark with go build. Didn't do shit. Oh, samples? FIR. Go build. FIR. All right, for timing report all. Oh, a CSV file. Oh. Okay, 0. Trace mem. Verify. Oh, it passed. Why are the files 0? Unified GPUs. Timing. Check the generated metrics CSV. Hello? Hello? Oh, I'm streaming. How was lunch? Oh, I don't have the camera with me. Lunch was good? Well, we can talk about this later when we're not on the stream because they can hear everything we're saying. That's good. That's good. Oh, I know you like the Peking duck. I ate the 2-day leftover salmon. Oh, yeah. That's okay. 2 days is fine. It tasted good. What are you guys talking about? We found an AMD GPU simulator, and we're trying to make it work. Yeah. Oh. They have some tests. I don't know what's going on, though. Yeah, well, I don't understand why it isn't working. Okay. Create a new... How come report all didn't report shit? Oh, let's try a different sample. What else is a good sample? ReLU. I trust ReLU. Go build. ReLU. Timing, report all. No metrics. What's a Haskell? I've seen that before. Let's figure out why report all doesn't report shit. Is timing being enabled, or do I need 2 dashes? What if I need 2 dashes? No. Trace viz, trace mem. Oh. Trace username is not set. A key to username, Bob. Oh. Well, it didn't. I tried to dial.
It's not working.
Well, I tried to dial that. Oh, it's going to MySQL. Oh, well, we don't have MySQL. Sorry. I should have known that port number. That's a famous port number, guys.
Do you want some light, or are you happy in the darkness?
We're mostly happy in the darkness.
Okay.
Do you want to say anything else to them?
No. I'm good. I'll see you later.
I'll see you later.
Bye-bye.
Bye-bye. All right. I'm not feeling that tea. We're gonna get a coffee and a pineapple bun. What do y'all think? Well, so first off, it looks like we're on the wrong platform. How do I change a platform? Navisim platform. Oh, maybe R9 Nano is right. What's R9 Nano? Oh. What's an R9 Nano GPU? Is that like an old GPU? Is that like a GCN3 shit? Oh. Yeah, this is GCN3 shit. Where's the RDNA? Oh, don't tell me it's like on a branch or something. All right, let's just look here quickly for branches. Create an AMD RX, okay. Done. GPU builder MU. So it might just be what's called MU here. Debug ISA. Builds an emulation platform. tried debug ISA too, but oh, here we go. Look at all these empty files. Oh, but these are things. ISA GPU1. Oh, look at that. That looks like RDNA 3, but to be fair, I didn't know what the previous one looked like, so I don't know. It looks like RDNA 3. Wow. Wait, so this thing kind of works. I wonder if we could wire it up to tinygrad. So Quaslin wrote this thing called Remu. That's an RDNA 3 emulator. It's very readable. I think it's in thread.rs, yeah. So you can see how it like parses the instructions and stuff. It's a little, you know, I wish it used some things that expanded the cons, but it's so short too. A lot of that is tests. Like when you get to the real base of the code, it's only 2,000 lines. It's all pretty straightforwardly translated from the manual. Yeah, these should have been constants, like from the manual, but other than that, like you can pretty easily, so this is like a VOPP instruction. So if we want to find VOPP, we can go to like RDNA 3 PDF, and it's not actually here, so it's like these VOP3P instructions. So if like instruction shift 24 is 2 1s, 2 0s, 2 1s, 2 0s, right? Like it's very like, it's super literal. Here we go. Look, we're pulling out the RDEST, which is here. It's written in Rust, which I'm now improving at. But this is cool. This is cool that this actually runs. So debug ISA works, but the other things don't work. Let's figure out why that is. Use unified memory. Changes nothing. Okay. The number of samples to filter. We just need to go larger. Something's got to be wrong. That should be outputting to the metrics. All right, so I know Go. We can code in Go, right? Who can code in Go? We can code in Go. Benchmark. Runner GPU driver. New runner. Okay, so here's where we get the runner. Start profiling server. Oh. I think that's just because it's like multi-threaded. Parallel engine. Let's look at the paper. Okay, good. We have the code now. Present NaviSim. It's open source. We found it. It's execution-driven simulator. I don't really know what that means. Recreates the execution instruction set with the help of the instruction emulator for RDNA ISA. Show up the instruction emulator being used. It's fine. When's it? Oh. Oh, I see. One's in either emulation mode. Instruction emulation mode can recreate execution results. Oh, wow. We should actually get this running. Simulation, yeah. Who knew that this was just available? I mean, it was good for Quaslin to write this anyway, you know, to learn about how GPUs work. Okay. So I kind of feel like just timing isn't working. Like that timing flag isn't working. Run detailed timing simulation. Report all. Like that's what would make sense if like the timing thing wasn't working. By the way, let's see if we can find the actual program here. So where is like, oh, Navisim benchmarks DNN ReLU? Okay. This is the actual code. There's a elf. Run it. So it's OpenCL code. You can see it's a ReLU down there. So you get global ID. It's the same thing we were doing before. Timing flag. Okay, if I do timing and report all, this should just work. I don't know why it doesn't. Okay, timing is clearly enabled. I don't really understand the profiling service. Collector didn't collect or something? Is there some way to like add like logging? The only thing that did work was debug ISA. Smoother output can generate lots of shit. All right. If we don't have timing, we build an MU platform. Oh, maybe we don't want timing. Okay. We can't report all if we don't put the timing flag. Trace viz. That's outputting metrics. Trace username is not set. Oh, maybe it needs MySQL. Oh no, maybe it only needs MySQL for trace vis, which is only enabled when I put timing. But why does this output nothing? Collect trace. Could it just be something where it's just not like closing the file? Nope, not that simple. That's what I'm doing. Okay, it should be writing metrics. I don't really understand. Wait, what? Something else is probably opening it. This is a common... No, it's fine. Why? It clearly writes to the file. Wait, what? Why does it close the file there? What the hell is this code? Am I reading this right? It's not deferred or anything? Wait, that's odd. After closing the file, it tries to write with it. But once the file is closed, writing to it should cause an error. What? I don't get it. You wrote a whole GPU simulator, but sometime you close the file before you write to it? Okay, cool. Yeah, that looks good. Like defer, that's the normal way to do that in Go. Okay, wait. So where's the memory trace written? Did they write the same bug? Nope. That looks like a different bug. Great. They were vibe coding, yeah. Vibes are off. Don't worry, it knew how to fix it. What, they also messed up that? Yeah, where's... what? Okay, that kernel seems really fast. Let's make it slow. One million ReLUs. Oh yeah, dispatch those kernels. You know what would make it faster? Parallel. That didn't make it faster. Okay, 1 million is too many. I'm not that patient. 100,000 values. This is terrible. We go? Yeah, no, this is their simulator. They spent all this time to write a simulator. They must be accessing the metrics in a different way. Because how is the metrics writing function broken? What do we think of this? Rainbow CSV from Mechatrooner. Sure, 12 million people installed it. I probably trust it. Oh, that's nice. Look at that. Thanks, Mechatrooner. Mechatroner. I maybe really use a boring simulation. Let's try a different simulation. Fire. Oh, well, I can't do ReLU. Fire. Timing. Report all. Metrics. Oh, read hit. 239. Read miss. 9. L2 misses sometime. Cool. All right, this is very sensible. You can get a lot of this data out of the GPU too. GPU sim works out of the box. I believe that, but mGPU sim doesn't support. What? Are you gonna? How long are you gonna go on about Rust? This is written in Go. Okay, you just gotta, deal with it. All right. Do we have anything else in here we want to check? Someone did this very carefully. Oh, I see. That's cool. Should we try to get that working? It might be kind of cool. Oh, okay, that's like pretty understandable. Mm. Come in.
Delivery.
Thank you. Well, I can't read properties undefined, so we tried.
Pineapple.
Wow, it's on a plate.
Has a napkin too. A latte.
Thank you.
You're welcome.
Maybe we want some lights in here.
Yeah, I was thinking it's so dark.
Oh, the lattes in this place are so good. Oh, you guys will never know the joy. Some of you might know the joy. Where's your AI girlfriend? Well, that's my AI girlfriend. All right, while we eat, let's read this paper. It almost looks like it's like Entropics. Like I was talking about this. Okay. I mean, like, this is exactly, when I talked about Entropics, this is exactly what I meant. How do you talk about information under computational constraints? Now, let's see how good this paper actually is, but I'm super like excited about this direction of science. Extracting actionable information from noisy, possibly redundant, and high-dimensional data sources is a key computational statistical challenge at the core of AI and machine learning. Yes. Information theory provides a conceptual framework to carry this information in mathematical various sense. Yeah. Oh my God, these people literally defined entropics much better than I could. They actually like did it. Yeah. Yes. Consequence new formulation that the community create usable information. That's a data processing inequality. Oh yeah. This generalizes the idea. Wow, I mean, this is the sickest abstract of a paper I've ever read if they actually followed through. But I don't even know like how you start. All right, boring math. Blah, 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 blah. Yeah, okay, boring, boring, boring. Yeah. What? The problem with papers like this is like, I have no idea if this is real or not. I'd be curious what else these people do. Yeah, okay. I mean, this paper defines this, like the space. Yeah, okay. So it's but does it talk anything about what the functions are? So I spent a lot of time trying to do math for the Hutter Prize and thinking about stuff like, well, okay, I mean, what I really want to know is what's the probability of the character at position P given the character is at position 1 through P minus 1. And I spend so much time like thinking about that problem and like looking for a solution in math. Like I'm like, okay, I was like, how do I use like Bayes' rule? Like, how do I do a perfect Bayesian representation of all of this? Like all the like less wrong circle jerk stuff. And like the answer was transformers. Well, the current answer is transformers. There'll be a better answer in the future, but like transformers, I understand. Like I can tell you what a transformer is. I don't know how it works, whatever, man. That's not that important. I can tell you how to use it. Which for so much of this stuff, it's like, great, you can define all this stuff, but like, how do I use it to answer questions? Okay, great. You want to talk about usable information under computational constraints? Cool. How many how many hours is it going to take on this GPU before it can get a 50 on MMLU or something? You know, I mean, like I think I see what they're saying here. They're just talking about some function. My predictive family is a set of predictive models the agent is allowed to use. So it's basically given the model, how much mutual information can you extract? Oh, why do people write math papers in somewhat confusing bullshit? Damn, this is so much better than the paper. I mean, this is a very good analogy. This is something that's always bothered me about information theory. Yeah. See, but now you lost me. There's no way you can tell me if I give you a plain text and a ciphertext in AES, there's no way I could tell you could tell the difference between a ciphertext and random things. That's the property of AES. Questionable. Main practice to compute it, just compute the constant to be predicting label using only the prior. No, come on. It's predictive model that uses and predict y. Get the constant to be lost. Model that doesn't use x. Okay, great. By the way, I love that this is open source, I think. I don't know what the 1776 edition is, but this is basically just DeepSeek. Interesting. Wait, this is actually a really interesting approach. And that's cool. That interesting. You do slightly better. You do slightly better on math if you're uncensored. Now, what I'd really be interested in is the what I'd really be interested in is does someone have this, but the Chinese version that goes into llama and removes all like the American shit? We identified people, yeah. Known to be censored by the CCP, right? So I'd love to see the Chinese one where they employed human experts to identify approximately 300 topics known to be censored by the US Gov. Interesting. Wait, what? But then they made it bigger? Because that's 1.4 terabytes. So they must have went to float. They didn't keep it in FP. They didn't keep it in FP8. No. America would never spread false information. There's false information number one. I mean that's the difference between China and America, right? Like everyone knows that there's certain things that are censored by the Chinese Communist Party, and everybody's aware of this. It is what it is. In America, there are certain things that are censored by the U.S. government, but you're not really aware of what those things are. The U.S. goes about it in a very different way. It's a censorship with American characteristics. It's still GTO to align with the West? Yeah, I definitely see a good thing China put tariffs on F-150s, so all the people in China aren't buying American-made car. Oh wait, no. See, it's so more like there are things that China puts tariffs on, obviously, like Instagram. There's a infinity% tariff on Instagram in China. Well, it's not actually infinity, right? Because you need a VPN, you can get around it. So that's basically a tariff on Instagram. But the difference is you want to put tariffs on things that have network effects, and you don't want to put tariffs on things that don't. One more joke, and you will get tax on GitHub bounties. Who's taxing me? Setting up a Hong Kong corporation. We'll see if they want me here. I'm gonna write a resume. Where were we? We got distracted. But this paper, this model's good. It's hard to use, like, I find Grok for coding often will just make things up. Grok seems to be the worst about hallucinating. It's the worst about hallucinating, but it's the best at being current. ChatGPT is very middle ground. ChatGPT is good if you like, I think it's the most reliable of the three. And then DeepSeek is the best at things that really require you to think. I haven't used Gemini. I don't even know how to use it. Like, fuck Google. Did they ever open source Grok 2? See, they always say they're gonna open source things. Elon like open sources nothing. It's kind of sad. Oh my god. Okay, I mean, there's like the only country in Europe to support Grok. Can you actually not use like AI in Europe? You know, Claude sucks. I don't know what's up with the Claude stance. I've never found it better than the other. I found it just a generation behind. The thing about DeepSeek is it'll actually think for a long time. I feel like 01 Preview would think like that, but then they nerfed the thinking. And Deep Thought just takes too long. All right, we've moved on to shit talking time. Okay, cool. Yeah, that's pretty straightforward. Yeah, I like Mercury. They're better than Brex. Brex was such a clown show. Brex like didn't approve my account. We want to make sure that you're validated through existing startup partners. You know, I told him, okay, well then no, you know, you don't get my business. And then they did something that I thought was really not cool. I told them, stop this. They sent me an email a week later saying your Brex account is ready, which I really think somebody looked it over and saw what happened, looked up who I was, and then pushed my thing through anyway. That like, oh, I have the Brex account now, I'm going to use it. I was like, absolutely not. So yeah, I mean, comma's still through Brex. Actually, no, I think we might have moved comma to Mercury too. I'm not that involved with operations at comma anymore. But yeah, no, I would definitely recommend Mercury. Brex also, like, they seem to go this route of like hiring the MBA types because they start to talk like MBA types. And whenever, you know, it's just death for your thing. All right. We read this paper. We read this paper. We read this paper. We did some noob introduction to GPUs. Let's see if people have anything else. We did some ranting about the US and China. We laughed at the Europeans. Always good, always good. No. You see, AI is illegal in Europe. You see, AI might upset someone's job. And it's very important that nothing upsets people's job. It's very important that there's no disruption here. We've had these ways of life for so long. I don't know how Hong Kong social life is. What do you do? So I told you what I did last night. I haven't played Magic the Gathering. I don't know, like what's social life anywhere? I go to parties sometime where we like play board games and drink beer. Going out clubbing? Fuck no. I did go to a rave. I did go to like a underground speakeasy type rave. That was pretty cool. I like things like that. The last thing I ever want to do is like, oh, let's go out and Lan Kwai Fong and listen to loud house music. Like, oh, house. Oh, no, I was like a techno rave. That was cool. Yeah, exactly. It just violates one of our 9 million rules. You can totally use AI. I should get into mahjong. I should learn how to play mahjong. That's right. Get hustled by some Asian grandmas. Sunday's a big social day here. Like people go out and like bring blankets to parks and stuff. I like to go for walks. A short meta? I don't know. Whatever. It's all fugazi, man. Where'd that thing go? You know, that thing we had before, you remember it, whatever. How long have I been here? Well, less than 90 days consecutive. Long Palantir, oh God. How do I manage to get a girlfriend despite being so low in the male dominance hierarchy? Bro, I'm about to demonstrate something to you. You see this? You are now banned from my channel. Sorry, no, I just blocked you. Oh no, ban. Yes, that's what I mean. Yes. So now, who's lower in the male dominance hierarchy? You or me? All right. Evil magician laugh. Oh, I wish this was more coffee. Oh, this coffee's so good. What else do we want to talk about? What else we got? Well, we went over a lot of stuff.
When it comes to the areas on GB202 amount to these inputs, the yield calculation of the chip area.
Let's find some like beautiful like GPU die annotated pictures. This is a 3000. This is like a 3080. Whoa, really? Which die is that though? That's a GA. They laid them out like that? So all the new ones seem to lay out like, I don't know which one that is. It's 8102. GA102. Just that's GA100. Okay, they put the SMs there. It's interesting. It's interesting that it's all laid out like that. If the uncensored DeepSeek is 1776, what would the uncensored GPT-4 have as its suffix? Let's laugh more at Europe. They need more demoralization than the US. I think they kind of don't. Like, the thing is, Europeans, US people, like,
do not realize yet that their empire is over. Europeans have accepted that their empire is over. They're a lot further along the demoralization curve. Yeah, I don't know. Like, I think about it a lot. I think about it a lot, like how you actually do. By the way, I don't think this is necessarily long term for America. I could easily see a world in 30 years where America has surpassed China again. But in the next 5 years, no way in hell. In the next 10 years, probably not. Which empire is just starting? Yeah, you're trying to get it on the ground floor? You're trying to get in earlier? You're trying to get in early? They're desperately trying to expand into Ukraine. Yeah, okay. Oh, you want to bet 1K that the US is on top in 10 years? On top in what? You think in 10 years that the US is going to be producing more electricity than China? You think in 10 years, somehow, the US is going to be higher than China on that? You'll bet $1,000 that somehow the US is going to be producing more electricity than China in 10 years? You want to do it for steel? You want to bet that in 10 years the US is going to be producing more steel than China? Yeah, you think? You think in 10 years? So like that's what happened in the last 10 years. You think in the next 10 years somehow that's going to get bigger than that? Oh, you're going to bet we have more compute than China. Okay, so you think the US is going to have more compute than China. You think China, do you know the basic input to compute, right? It's electricity. So it looks like if current trends continue, China's on track to have 4x the electricity of the United States. So you know where all the chips are made, right? You do know that they're made in the Republic of China, right? The Republic of China. I don't know if you guys have ever like looked at a map, but like here's China and here's Taiwan. Right? Some just because some like, loony people in the US, which is by the way all the way over here, think that somehow, the chips from here are going to keep going here. I kind of think the chips from here are going to start going here. Kind of makes interesting how close it is. Look, they could like practically throw a chip. You could stand here, right where TSMC is in Hsinchu, and you could like throw a chip to Guangzhou. Here you go. Here. You want an H100? Here you go. You want a B200? Here's a B200. Here you go. Oh, no. They're going to continue to come on boats all the way over here. Yes, definitely. Yes. Come on, guys. All right, so who's still betting? Who's still betting that somehow in 10 years the US is going to be on like any metric ahead of China? Oh, you can do stuff with more efficient processes. So for some reason the US is going to get these more efficient processes and the Chinese are not. Wait, you'd still think we'd be on top. This is it. You guys think you're on top on some like, it's on freedom metric. The fuck is freedom metric? You'll be willing to shake. Cybergenic, in what metric will the US be on top in 10 years? The US will be ahead in DEI. All right, good. I'll give you that. Yeah, I mean, there's going to be fabs all over the world, right? I'm just like you guys are aware that Taiwan is a part of China, right? And I'm not just saying that because I'm here, right? Like you can look at the history. You think the best AGI labs are going to be in the United States? I mean, there's okay. There's more of a possibility of that. Well, the U.S. is going to take over Greenland. That's true. We're going to get all the fabs in Greenland, right? All the chip manufacturing capacity in Nuuk. Oh, the U.S. dollar is backed by military. Oh, interesting. Okay, here, let's see. China Navy versus U.S. Navy. All right, let's see. Yeah. Production. Yeah, okay. Oh. All right. Total battle force ships. Notice how it looks like everything else. Holy shit, they look identical. It's almost like all these things are correlated. And this idea about America somehow having the best military is utter and complete cope. Also, here's an interesting asymmetry of America's military and China's military, right? If you're talking about something like Taiwan, I mean, the U.S. would have to project power across the biggest ocean in the world, whereas China, I could literally sail this in a day. Give me a sailboat, Guangzhou. If the winds are good, I'll sail right there. All right. So hello. Oh no. The U.S. has what? What, drone production? You're going to try to tell me the U.S. can somehow produce more drones? I want you to imagine an American-made drone. I want you to imagine the union worker putting the propeller on the drone. And then I want you to think of every modern Chinese factory video you've ever seen. Okay, you have better tech. The U.S. has better tech. By tech, do you mean intellectual property? Come on. Why are so many Chinese wanting to come to America? Some Chinese people want to come to America, and some Americans want to come to China. It's actually easier to be to be Chinese and come to America than it is to be American and come to China. But is that even how long is that going to be true for? When does that switch? When is it easier for an American to go to China than it is for a Chinese person to come to America? I think for tourism, it's easier for an American to go to China. It's interesting. Yeah, US only has best LLMs, everything else China's winning. I've heard they have like sick video gen models in China that are better than the US's. You have no idea what the US military has. I heard a good saying about this once, and it's kind of like, which do you think is better run? The DMV or the CIA? And the thing about the DMV is everybody can see how the DMV is run. Everybody can experience the DMV. So at least there's some check on it. Why do you think the CIA or whoever you think's running the military is some bastion of competence, whereas the DMV looks the way it does? Yeah. I mean, why? What makes you think, you know what? All right. So that's the U.S. champion math team. Interesting. It's interesting what I notice about all of them. Okay. So what is it? What is it that you think that what is it that you, well, here, I mean, we can also look at the, the Chinese champion math team. And for some reason, interesting. Oh no, that's the US one. Sorry, I got them confused. No, that's not, I'm not trying to make like a racist point or anything. What I'm just saying is, if you believe somehow that America will have the best Gen AI tech in 10 years, or the best LLMs in 10 years, I ask you why. Is it human capital? Is it resource capital? Is it intellectual property? Like, what is it? For everyone who says freedom, I'm very curious what you mean. I've experienced much more freedom here than I have in America. Because you know why? Here, I feel that I can walk anywhere, certainly anywhere on this island, at any hour of the day. And nobody's gonna harass me, nobody's gonna try to mug me, nobody's gonna touch me. Like, you're just not gonna have that, right? That's the thing that I want freedom from. Most of the infringement on my freedom in America isn't coming from the government. We can talk about the tax rate and whether that's an infringement of freedom. So that certainly infringes on my freedom. But again, there's a whole criminal, like the amount of times I've had to call the police in America is insane. That is freedom. When you speak of freedom, you speak of political speech. Why do you want that? How has your political speech worked out for you? Why is there no Starship in China? I mean, we can look. The US and China are here, so we can look at space launches 2024. Here. So here are the orbital launch attempts. So you see it's dominated by SpaceX. Elon, in a way, gives China a run for its money. If you let Elon operate, but a lot of these are Chinese startups. Colored. Right? Yeah, so there you go. I mean, that's a pretty nice one, actually. America's certainly increasing there. If you count America, I mean, you almost want to, like on all these things, for like electric cars and for rockets, imagine Elon as a separate country from America. Imagine Elon as separate from the USA, right? Like, imagine Elon. I don't know. This is a real place where America has an advantage. If Elon, yeah, it's Elon versus China, you know? And yeah, you know, BYD makes like electric cars and there's a lot of hype, but like you can compare BYD to Tesla. You can compare BYD to Tesla and you can see like even competitors, right? You can see a world where BYD pulls ahead in some areas, where Tesla pulls ahead in other areas. You look at like that's a fair competition. When you compare something like Tesla to GM, it's a joke. Well, it's not about Elon engineering the rockets, right? Like China didn't engineer the rockets either. People in China engineered the rockets. But what Elon can do is bring the people together to actually get the rockets to go up. You say the West is at least 10 to 15 years ahead in fabs. I mean, again, what do you mean by the West? Right? And also, like, yeah, you can break fabs down. Sure, ASML is ahead. ASML's EUV tech is, I think 10 to 15 is a bit of a stretch, but I think 5 to 10 is plausible for what they're ahead of China. You can look at like the China domestic EUV machines, and I bet they don't really work yet. Yeah, New Zealand has Rocket Lab. I'm going to New Zealand this year. I'm excited. ASML is half American. Interesting. I didn't know that. Yeah, I thought they were Dutch. So, does anyone still want to bet? If you gave me like who's going to be ahead in space launches in 10 years, I think there's a chance that it's America. You'll define the West. Sovereign states that agree with principles of individual autonomy, freedom of speech, privacy, and civil liberties. I mean, I don't know. Like, some of those things are kind of true, but they're also kind of marketing material. I prefer to, like, I think a lot of those things are platitudes to deal with, like, cope. The things that I would prefer in a country are, like, wealth and abundance. And not wealth and abundance from, like, sure, you can have, like, an oil country. I wouldn't want to live in one of those. I'm saying, like, a society where a lot of the individuals are creating value. That's a good society. Yeah, I mean, sure, I'd say that the US has very good freedom of speech laws. The US always has. And yeah, this is something like the US really values. I think it's cool. Like, I like freedom of speech, but I think there's a flip side where, like, freedom of speech for an individual to criticize the government is great. Freedom of speech for a large corporation to hire a lobbyist to influence the government, I mean, that falls under freedom of speech too, and that's a lot more problematic. All right, we're off the rails here, but I really, every single person who thinks the US is going to be ahead in 10 years, anybody who wants to make a concrete bet on that, I'm interested in making that bet. And we gotta pick some number that can be measured. Even saying like it's going to be ahead in AI, right? Like is DeepSeek ahead of ChatGPT? I don't know. It's like it's hard to argue, right? Like maybe, probably not, but it's not like steel. I mean, I don't know about the justice system in China, but I do know that in China, it's probably a lot easier to rent an apartment than it is in the US. I can't believe how difficult it is. I cannot believe the level of like applications and checks. But then I can believe why every landlord wants to do this. Every landlord wants to do this because I could, be a deadbeat drug addict who stops paying rent and still lives there. I think that's a lot less of a problem in China. You're uncertain the US is still a democratic country in 10 years. Well, the best possible outcome here is Elon becomes a popularly loved dictator. If Elon becomes a popularly loved dictator, installs a good set of lieutenants, starts really thinking about how to build institutions, if the Doge doesn't just stop at destruction, like if Elon's game is 20 years long and he truly builds new institutions in the US, and you need to have an open borders policy. If you don't basically have open borders, then I see no way the US could be competitive with China like in generations. But if you have open borders, and you have a state that's like turned around, yeah, the US can beat China again. Elon could do it. I'd give Elon a chance. If Elon was the dictator, I would give Elon a chance at turning these metrics around. I'm not sure he'd win, but I'm not sure he'd lose. Anything that looks like the current US administration, I am so sure they'll lose. And it's not just Elon. It's Elon-like leadership. He cheated at Path of Exile because he had a dude grind his account for him? What do you mean cheated? Elon can't even turn X around? I don't know. It's like, it's better. I think it's better than it was. I mean, Twitter was always a toxic cesspool, and now X is a toxic cesspool. Wow, you're telling me the richest guy in the world decided to pay to not have to grind in a video game? Based. Acts progressively more erratic. I don't know. I think this is a lot of disinformation. Like, Grok is good. Again, like, don't worry about, why are you so arrogant and to think that you can, like, judge like somebody from these kind of vibes, right? Why do you believe you can have that opinion, or do you outsource that opinion, or that shit doesn't matter? What fundamentally matters is output. Are things being delivered? Because he contradicts himself? I don't know, Grok's pretty good. SpaceX is launching Starship and catching it with the little fingers, right? China can't do that shit. The US is 10 years ahead of China in spaceflight. That's definitely true. I mean, China has an interesting strategy to catch up. The US is also ahead of China in airplanes, right? Like China's eventually going to launch the, I think now they're flying domestically, but like it's a shit 737 A320 clone. It's like, that's not a great airplane. Their next generation will probably be stuff that looks like the 787 and the A350. But then what's going to be so interesting is the generation after that. So in like 20, 30 years, I bet you the best planes will be Chinese. You're 10 years ahead of China in so many things. Literally name another one. What do you think? I'm not so sure about that. Software? The amount of gangs. You think China's gonna have gangs in 10 years? You're 10 years ahead in school shootings, yeah. Okay, so wait, software, hardware, what? Okay, so again, like you can't compare a Boston Dynamics Atlas to a Unitree H1. You have to compare per dollar. Software? I don't know. Do you see the DeepSeek kernels? Like, look at DeepSeek compared to like Llama, right? Oh, no. India is no China. I do not think India is ahead of us in anything. China has won 0 Super Bowls. That's true. Boom releasing a commercial supersonic aircraft. They've raised $151 million. That's it? And they're going to build a commercial aircraft? Yeah, that's not going to happen. All right, let's see the one they actually have. Yeah, okay. They're going to build a commercial passenger aircraft? No fucking way. Right, so for reference, this amount of money is half the cost of a single Boeing 787. All right. So you boom, or like one 787-10 with a bunch of bells and whistles. Right? The 787 cost Boeing $32 billion. Sure, Boeing's inefficient. Boeing's inefficient. Maybe you could be 10x better than Boeing. You're still off by an order of magnitude. So yeah, might this company eventually grow into something that can build a commercial plane? But that looks like something could be built in a garage. Which, like, respect, but don't think this person's ever going to, like, in any amount of nearby time, build a commercial passenger aircraft. No, it doesn't seem like a scam like Nikola. Though to be fair, if Sam Altman's involved, it's probably a scam. What America has that China doesn't: companies' market cap, fake dollars. China has mid girls. They don't have big booty Latinas. All right, they'll have the big booty Latina visa. Isn't the fact that most of the world is using American software something? America's got a few, like, America's a good bit ahead on, like, chips still. Right? When you look at that More Threads GPU, I mean, the More Threads GPU looks like something that's 10 years old. Have I looked into Doge and maybe sent in some of my ideas? Yeah, that's exactly what they need, me to send in ideas. Yeah, I mean, I have a small indirect way that I'm contributing to Doge. I very much want to see Doge succeed. You can, there's, no, we're not going to go into that. Wait, again, for your money, what is the actual bet? We need a number. We need some number that we're betting on. If Boom had the White House behind them, how many electric car chargers did they install? How many broadband things did they install? If Boom had Elon behind them, yeah, I'd kind of believe in it, actually. All right, we're off the rails here. If anyone wants to make a bet on some number, right, let's get on some number. No, I mean, look, there's ways to save America. Here's something I would do. Like, can we, like, make America like a good place and then set up little Taiwan and be like, look, anyone who wants to, anyone from Taiwan who wants to come move to America and, like, set up sick shit here, like, you can, right? Like, that'd be awesome. But no, like, America's not going to do that. You're going to have to go through some bullshit and, like, Look, I don't really believe in open borders, right? If every person if every Somalian wants to come to America, like every person in literal war-torn Somalia, no. If every person in Taiwan wanted to come to America, yeah, any Taiwanese citizen who wants to come to America, yeah, you should be welcomed with a work visa and open arms and a path to citizenship. Absolutely. Right, you gotta like look at the country, right? Think just here, every country that has a murder rate lower than the U.S., if you'd like basically an open border with the U.S., I don't see why not. Can Europeans come? Absolutely, absolutely. No, all countries don't have murder rates lower than the U.S. I mean, you even got to be careful with Mexico there, right? Like, just look at your country's murder rate. If your murder rate is lower than the US, you should be welcomed, at least with a work visa, right away. I mean, yeah, you got to be careful with South Africa. I'm not saying if your murder rate is higher, you absolutely can't come, but we do need more scrutiny. Zambia has a lower murder rate than the US, then maybe everyone from Zambia is allowed. Zambia nice? What? I don't know. I've never been to Africa. Nah, that's... Interesting. Wow, that's actually higher than I thought. Scary. Can you like go to Zambia and like chill? Is it like chill? I love how like you click on the pictures, they're just like, like let's compare this to the pictures for like some random place in Taiwan, right? I'm not gonna, yeah. Yeah, let's go to, well, that's probably a bigger city. Actually, they're kind of similar. Who picks these pictures? Copperbelt Energy headquarters. Who? You're telling me this is who did that kerning? Yeah, yeesh. They really like the Z-Mart there. I'm surprised this is the one for Taiwan. Imagine the ones that didn't make the cut. No, I don't know. I don't know how they picked them. That's more representative of what I saw in Taiwan. Oh, actually, I don't know. I rode my bike through that, actually. I rode my bike exactly here. I rode my bike exactly on that little hatched path. They have, like, some cool bridges here, too. Yeesh. They really like the you could have made those the letters a little smaller. I mean, okay, it's not like this level of bad. It's not like this level. I mean, but like, no, okay, the Taiwan one looks better. Like, the countryside really does look like this. It's really beautiful. Oh yeah, see that's representative. I don't know why more of the pictures don't look like that. Oh. Oh, that was pretty nice. Okay, okay, that's a nice convention center. Yeah, yeah. I mean, I don't know if that's just the choice of font or... All right, Lincoln Park. Copperbelt University. Okay, okay. Swimming charges. Adults, K100. Children, K50. No lifeguard, pay at the bar. Okay, okay. All right, reasonable. It's a nice picture. So, but is it, wait, no one answered my question. Is like Zambia chill? Does higher education in the US suck? So in the last 10 years, a lot of the colleges, you'd be more and more infiltrated by the DEI garbage. Like there really is, there's a mind virus and it's in the universities. If you're the type of person who can stay resistant to that mind virus and focus on whatever esoteric math or science thing you want to focus on, then the US universities are very good. But increasingly more and more people are being pushed out as they enforce ideological purity, right? Like the college, these are the same people who wanted to do things like, I was just thinking, it's like, wow, the US like had its like shit cultural revolution, And then in like 50 years, maybe it'll be sick. I don't know. No, we didn't actually get to the killing. We didn't actually get to the killing of a large number of the population. That's where cultural revolutions always need to go. I was in Cambodia. I went to a bunch of like the Cambodian genocide things there. You feel like you're the only person in your college who doesn't buy into DEI, but you have to stay very quiet. Yeah, I mean, look, I'll tell you right now, like, do not kowtow to that stuff. And you start thinking, oh, well, I'm just going to do it for this one thing in order to achieve X. It's kind of like the way this stuff kind of works is like it's kind of like a cult. Like if you buy in, they're getting you to, what do they call these things? Struggle sessions. It's kind of like a struggle session. UT Austin. You mean the Joe Lonsdale thing? I'm not bullish on that. Every college that starts with undergraduates is a scam. Any college that, if you want to build a college, and I think a lot about building a college, you need to build a research institution first and then undergraduates second. And everybody who's not following that path is building basically a glorified prep school, like a high school, DEI girls are very easily sexually available, right? No, I don't know about that. I don't know. I wouldn't. You know the expression like don't stick your dick in crazy. People who are like it's one thing. Like look, someone like there's mild forms of this, and then there's extreme forms of this. The mild forms of it, sure, everyone has like some mild ideas, but the people who like believe in this stuff militantly. I don't know, I wouldn't involve myself with those girls. Oh, the right wing is a mind virus too. Oh. I want George to walk into any seemingly top college in the US and see his reaction. I mean, look, I've seen it. I was there right at the beginning of it. I'm like, I don't know, but I also hear from a lot of people that it's like you can avoid it. Like, sure, yeah, there's going to be a table set up for Asexual Awareness Week, and they're going to ask you if you want to talk, and you can just say no, thank you, and you can move on with your life and be like, okay. All right, come on. Let's stay off the stupid things, right? Let's stay off the things of mind virus too, because people like go off on it. You can't avoid writing DEI statements in top grad schools. So literally, you should just say no, and you just shouldn't participate in that system. Yeah, sir. This is a Wendy's. Yeah, you can literally just casually avoid it, and the hard sciences seem to not be too compromised by it. I think that's generally true. I think that's generally true. So are these? Look, I mean, I went to CMU for a bit, and it was okay. It was a lot worse in 2014 than it was in 2012, and I do think it's gotten even worse since then. But I would bet that operating systems and compilers are still really good courses. And oh, if you think you're getting a diploma and that's going to be worth anything, if you're not going for the learning, you should leave right now. The diploma is completely worthless. Wait, the diploma is actually worthless. You guys are aware of this, right? No company cares anymore. The companies who do care aren't even going to exist in 10 years. And this is why Roy Lee is so right. It's like people are he's throwing away his future. Are you kidding? What future do you think you have? You have to have built Google to get a job at any software engineering company. As the founder of 2 software engineering companies, you don't. You just have to be able to produce value. That's literally it. You want a job? You want a job at TinyCorp? Start contributing to TinyGrad. It's actually that easy. Contribute to TinyGrad and show that you have a loop that you can, I mean, the difference between someone who contributes and like solves bounties and someone who we hire full time is somebody who can consistently and independently improve the code. Anybody who can consistently and independently improve the code, I'll hire full time. I mean, this is, yeah, the trolling of LeetCode is incredible. I don't know, but also like the other side of the trolling of LeetCode is if you're a good programmer, you're pretty good at LeetCode. I'd be curious right now if somebody gave me LeetCode problems, like would I pass an interview? If I could easily pass the interview, then it's fine. If I don't pass, then okay, something's wrong. But I don't know. I don't know where the bar actually is on LeetCode. Do one hard. Let's like look up a LeetCode hard. Someone want to give me a problem? If it's have you seen this trick before, I probably haven't, and that stuff's stupid. Didn't I destroy advent of code? Yeah, back in the day. Now you should just use an LLM. All right, LeetCode hard, page 1. Okay. So let me explain how you solve a LeetCode problem. So in this window, you bring up an LLM. And then you click here. And then you do this, say Python solution there. Oh, no, I have to actually paste correctly. No. Let's refresh my LLM. Python solution. Oh, this is taking me a long time. Okay, cool. So we're going to do this in Python. In this format. Okay, you should probably have a faster LLM ready to go. Because if you have a slow LLM, the interviewer might know that you have a slow LLM. Wow, this is really slow. Wow, you're just supposed to know the answer already. Oh, I'm sorry. Oh, why don't we talk about my dog? Yeah, I just got a new dog. Yeah, no, I'm thinking through the solution, but first I want to like talk about my dog a little bit. Yeah, no, his name is Puppy. Yeah, I thought it was kind of ironic, you know, like I named my puppy Puppy. Yeah. So, you know, his name's Puppy, and sometimes you know, his name is Puppy, and oh, okay, oh yeah, no, yeah, I see. We're gonna have to, well, first we're gonna have to like handle the edge cases. Yeah, no, and then yeah, so no, wow, I really should have prepared for this interview more. You know, it just takes me a long time to like think through these things, and wow, this is really wow, this is we're still going here. Like sometimes DeepSeek really does this. Yeah, oh, we don't even have that. Oh, and that one's not gonna work either. Oh no. No guys, I failed the interview, sorry. Oh yes, here we go. It's even in the right format. Oh no, sorry. Here, I got it. I just thought everything through. Everything just came to me. Okay, here we go. Yep. All right, cool. Yeah, I solved it. Would I use an LLM for admin of code? I used an LLM this year. I used an LLM. I even wrote a script and everything. Like it's not. I don't know. And then I kind of got bored. I got bored with it a few problems in. I'm just kind of like, if this is what it's going to be, then why, like the competition had a good run. But as an actual like practical thing, the leaderboard, they're like, oh, you can use an LLM, but you can only use the LLM to help you. Don't copy and paste the problem. Like there's just no longer a real line. Okay, do you really want to like think through one of these? All right, department top 3 salary. Oh geez, what is this crap? Who earns the most in each company's department? Write my MySQL query statement below. What? Oh God. It's a MySQL problem? Oh, what's candy? There are n children standing in a line. Each child is assigned a rating value given in ratings. You're giving candies to each children. Each child must have at least 1 candy. Children with a higher rating get more candies than their neighbors. How big's n? Not that big. How long do you have in interviews to work through these? OBS is not centered? What do you mean by that? If I have 40 minutes? Yeah, I can do this in 40 minutes. Yeah. I have to solve this like one problem in 40 minutes? Yeah, I can do it easily. I don't know what FireShip is. I mean, so like what I would actually do here, the way that I would actually solve this is I would use Z3. And like if they have a problem with me using Z3, it's just really easy to express like this exact sort of constraint. I don't know, maybe Z3 wouldn't, maybe that's too many variables for Z3. But I would express it first in a constraint solver, and then think about how to explicitly solve for those constraints. I don't know, like I feel like with all of these, it's like, sure, you could push people on like knowing whatever the algorithm is. No libraries. Yeah, okay. Do you guys want to actually do this? 40 minutes time was running. I have to sign up for fucking LeetCode. Nobody wants to do this. LeetCode is contrived. The minimum number of candies you have to distribute the candies to the children. I would not partake in rating small children and distributing candies to them. No, I see. I get nerd sniped by this stuff. Not speaking is a red flag. All right, you want me to speak the whole time? So we have the ratings coming in, and we have to return the minimum number of candies. Well, so the absolute minimum number of candies is going to be the number of children because each child must have at least 1 candy. And then every time we have, all right, so there's a few cases that can be done here. So we have a child, and either this child has, children with a higher rating get more candies than their neighbors. So we can think about the case like this. And there's high. So we can think about all the possible cases here. Higher. So how many possible cases are there? Same, higher, same, higher, lower, lower, and we just do all that same stuff but lower. And then we also have to do the same for lower and higher. So those are all the possible cases. And every time there's a change. Okay, so whenever two children next to each other have the same rating, we can just remove them all. Because that doesn't matter. They're all going to have the same number of candies. So we just have all the step changes. It's a Scala interview. I don't know. Yeah, I mean, this stuff's kind of stupid. This is a dumb way to interview people. This is a real dumb way to interview people. So I haven't really thought like this in a while. Like, this really is a much less useful way to think now. You should be outsourcing this kind of thinking to LLMs. But did I ever say LeetCode was smart? What? So we used to have one. We used to have one at comma, a programming screening. But our programming screening was not LeetCode. Our programming screening was not algorithms. It was literally like, can you write Python code to fetch a web page and extract an element from that web page? So you should have like some basic. No, I mean, TinyGrad's just much easier because it's just open source. Okay. So you got to deal with each one of these transitions as being more or less. So first we'll compact it to that. And then I feel like we can do an iterative algorithm, but that probably isn't optimal, right? So you can quickly get like a solution with an iterative algorithm where first we're going to go through and like find an unsatisfied child. Okay. So candies equals 1 times length ratings for I in range if n equals length ratings 1 times n for I in range n. If rating sub I is less than rating sub I plus 1, candies sub I All right, did I solve it? I'm not logging in to find out. Oh, my final login. No, don't lose my candies. I worked hard on that solution. Is it good? No, I'm nerd sniped. We're solving LeetCodes now. Look at the LeetCode solving stream. We're solving LeetCodes. We'll do it in Vim for old time's sake. Oh, I can't believe this. This is a LeetCode solving stream. Use tabs or something. What? Oh, come on. What is it? Set ET? It's been a while since I've used Vim. All right, loops forever. Great. Oh. Take away a candy from that child. That's right. Okay, 3 and 4. Nope, it was supposed to be no. Okay. What? Did I even understand the problem? I don't understand why that's ever correct. Why that's the output of candies? That shouldn't be the output of candies. Oh, it's not the output. Why does that get 102? What? Ratings I is less than ratings I plus 1. And candies I is greater than candies I plus 1. So why does that not just increment that by 1? Why does that give me 2 there? Oh, also, how did that even become 0? What did I just like? How did that become 0? Greater than 1. All right, 1, 1, 2. No, but see now, because that one has to be incremented. In fact, why do I ever have to decrement? Can I do this only by incrementing? The only time I might have to decrement okay, comment that out for now. Let's focus on that case. So this child is a lower rating, so we're going to have to increment the first one. Let's just do this a little differently. Okay, so while that rating is true, and this candies is true, let's increment the ratings of the first child. No. Now we can't increment ratings. Sorry, what am I doing? What am I doing? All we can do is give the child more candies. Okay, so while the rating of the child is greater than or equal to, and the candies is less, we give the child more candies. And candies is less than candies I plus 1. Less than or equal to. All right, now we're getting 2, 1, 1 because we forgot the last child. Oh, this, okay, wait. So let's think this through for a minute. So can we like solve this like inductively? If you fix the beginning of the list, is there any reason something later in the list? Oh, I guess. Yeah, if you have like a sharply descending thing, you're gonna have to increment all the previous ones. Okay, 1, 2, 1. So now let's just do this for the last child. Ratings, n minus 1. If ratings n minus 2 is okay, let's just do the last child explicitly. Ratings, so n minus, if 3 possible cases. Same, children with a higher rating get more candies than their neighbors. So if ratings n minus 1 is less than ratings n minus 1, candies n minus 1 equals candies n minus 2 plus 1. Else. Oh, that's if it has a higher rating. Oh God, no. Okay. This kind of like gets at how to do the whole thing though. So if they have the same rating, then we have to give them the same candies. We can probably just use the same logic to then solve the whole thing. If they have the same rating, if the rating is same, need same candies. That's a true fact. If second, last is higher rated than second to last. Last gets one more candy. That's fine. If last is lower rated than second to last, last gets one less candy. If candies sub j equals 0, can't have 0 candies, add 1 to all. We got 5 for both. Oh. Oh, okay. If they're the same, they don't need the same candies. That's wrong. Oh no, this is complicated. Ah. Oh, this is really complicated. Check chat. Well, I'm not checking chat. We're solving this alone. Okay, if the rating's the same, they need the same candies. This is false. With a higher, okay, so wait, so I was wrong about all that stuff about the same. Okay. If the rating is the same, I could actually do whatever I want. If the rating is the same, maybe I just skip it. So then I don't need to add 1 to all. So we'll get there in a minute. Rating revised. If rating is same, ignore. Anything is fine. Right, now we have a problem with that one being 0. Okay. For I in range j to 0, -1, -1. If rating sub I -1 equals rating sub I, break. Rating is same. Anything is fine. Okay. Where does it break? Cool. I solved the examples.
Is that right? What did I do wrong? What did I do wrong? There's no way it's that algorithm. There's no way it's an O of N algorithm. God, I'm gonna sign up for LeetCode. See, wanna know the truth about this? I look at this and I can't stop. And unless you're like that, don't go work at a tech company. Get the fuck out of technology. That algorithm's not O of N, it's N squared. Some test cases to test. All right, the answer to this is 13. Can you, I don't just want the answer. You got to give me the candy distribution. I got 13. What else we got? You got any more examples for me? Did I get it right? You got it right already in 8 minutes. All right, cool. Glad to know I can solve LeetCode hard. Glad to know I can have a job at a large tech company. Okay. Did I actually solve it? I don't know. Maybe I was just like over-indexed on like how hard these things are. Oh, you ran it for me. All right, thanks. Great. Cool. I can get a lot of job at tech company. All right, so look, here's the truth. Actually, if that's the difficulty, that's fine. If that's the difficulty for an interview, that's fine. Like there was no, if it's the kind of thing where, oh, you just have to have like max flow memorized or Ford Warshall or whatever, yeah, that's stupid, right? Or if it's the kind of, any interview problem where you have to see a trick, it's stupid. But there was no trick there. It's just like, okay, go through and solve it. Right? You guys are like trolling me probably. It's probably actually like, no, you need this like dynamic programming n squared search. No, come on, that's a reasonable interview question. If a guy who wants to join TinyGrid can solve this problem but has a hard time contributing to TinyGrid, no, of course I wouldn't hire him. It's a much better interview process, right? It's a much better interview process if your test set and your train set are the same. No, anything that's speed-based or that you have to practice is stupid, right? Like, okay, sorry about my arrogance, but like, if I can't solve whatever it is, it's not a good interview for a tech company. Like, I might have other problems with me that a company might not want to hire me, but if a company's upset with my programming abilities, I mean, you know, that's I don't know where that bar is. And like some people have been posting like a bunch of like those hedge fund questions. Oh no, I'm sure there's some LeetCode hards you could give me that would just happen to stump me for 3 hours. That's not contrived. That's programming. If that's the level of interview question, that's programming. You don't need to know any algorithms to do that. You just need to think it through. I think that some of the hards are stupid. Like, I don't know, like the median, I know the median subset one is like, again, if you have to know the algorithm, if it's a question of grinding, yeah, I mean, then it's stupid. Anything that people are going to grind for is just like not a good interview at that point.
And again, I'm not saying that companies should use this as an interview. It's a weak predictor of the thing you want. I would never, the comma had, I don't think we have it anymore. I think now comma is all programming challenge based. But we used to have a programming challenge, like we had like, you had to do like 4 questions on one of these platforms, but they were a tier easier than this. They didn't really require thinking through problems. They required actually just kind of being able to do things. I remember like some of them were as dumb as like fetch a web page and yeah, like parse this data out of it and then calculate the mean. Yeah, this is. Interviewers are arrogant and they throw impossible problems to boost their ego. You know, I failed a Jane Street interview. I did a Jane Street interview, and yeah, it was kind of like it was something I hadn't seen. It was like basically that you can create 2 to the n things in like a functional programming language. And this is back before I even had as much Python experience as I had. I was doing things mostly in C. And like, yeah, it was a question that was assessing if I had spent the last 5 years doing functional programming more than anything else. It was about yeah, 2 of n constructions. You can use something that's O of n to construct objects that are 2 of n. 2 to the n. It's like really obvious, and I'll never forget the problem. But yeah, no, they rejected me on the interview, and like, yeah, I don't know. I don't think it was a particularly good. It also wasn't like a coding problem. I actually solved the coding problem. They gave me a coding problem and I solved it, and it was so weird actually. Now that I think about it, like what I failed was like the got you questions. The guy was like how big a thing can you produce with an O of n calls to a function? And like, I guess I didn't really like it's a very functional programming way of thinking. And then he had to, like me to do something where you like traverse the list. And I used ID in Python, and he kept telling me it was wrong. And I was like, I don't think this is wrong. And he's like, what about the garbage collector? And I'm like, Python's garbage collector is non-moving. And he's like, oh. Yeah. So I don't know. No, I don't think the problem was that creative. I think the problem was literally like, are you thinking in a functional programming language or are you thinking in an imperative programming language? And again, it's a totally fine screen if that's what you're looking for. But the question would like, even someone who's a very good programmer, who hasn't just spent a lot of time thinking in a functional way would get. And like, you know, I saw something in someone in Lex where I mentioned that I wrote a compiler in Haskell. I wrote my compiler for CMU's compiler class in Haskell. And like, it doesn't mean I consider myself good at Haskell. Like, not really. You saw me at Rust today, so apparently I'm at Rust. Go I can kind of do, but I ended up interning at SpaceX that summer. SpaceX's interview question was basically explaining. First they had me do like the typical like walk me through a hard problem you've encountered and how you solved it. I forget exactly what I said, and then they had me talk about like ground bounce. And just like understanding that even your ground plane has resistance and your ground plane is going to be pulled up in areas if there's current drawing, then your ground could go. And like they were asking me like, do you know that like a transistor triggers at 0.7 volts or something? Like all very reasonable EE questions. Do I think it's worth learning programming? What? I don't know what you mean by that. Really, let me tell you the truth. If you have an IQ that's like sub 110, sub 120, I just don't know if you can do this. And I think that's the real truth. And I think that there's a lot of taboo in just stating it like that. You know, we live in a world where like people can overcome. But like, yeah, maybe 115. But if you have an IQ of 85, you'll just never be able to solve a problem like that. And that's the truth, right? You can grind at it your entire life. And maybe you can grind at explicitly LeetCode, but you're not going to be a software engineer. And like, that's just like, I don't know any other way around that truth. Bro woke up and chose violence. Yeah. I mean, it's not violence. I think that the even sadder thing is telling anybody that they can just practice LeetCodes and eventually get good at them. And like, programming is a skill you can definitely practice. And the sadder thing I see is when I see like 150 IQ people who can't program. Like, you can program. Go spend, 5 years doing it and you'll be good at it, right? Like the only reason you can't do this is because you haven't spent time doing it. And that's less about stuff like this. Like, these kind of things are almost straight up IQ tests. Like, there's some amount to which you can memorize the tricks, but I really don't think the companies want you memorizing the tricks. Yeah, no. Look, if your IQ is like 115 or 120, yeah, I think you can learn to do this. But if your IQ is 85, you can't. If you take a few hours for a LeetCode hard, you should work at McDonald's. Like, I mean, something I can think about is like, when I was like 21, 22, I was just as good at that problem as I am now. When I was like 15, I think I was less good. I'm not sure. But no, it's not a trick. I mean, like, they don't want you to know a trick. They're trying to see if you're capable of like thinking through stuff like that. There's not really different types of intelligence. There's limited, and sure, you want to talk about different types of intelligence, sure, like, sure, I think someone who's like an artist or something, maybe that stuff's different. Like, maybe there's like convergent and divergent, but there's not different types of intelligence that make you good at programming. And this is, in its purest form, what makes you good at programming. Candies fail. I got one wrong. This might be wrong too. This might very well be wrong. And again, if this goes into like, you have to, if you give me an example, I'll go through it, but this can very well be wrong. But it's not about even like whether the solution is exactly right or not. It's about whether you're capable of breaking the problem down into subparts and like understanding what the constraints are. Like, can you see, first look at how I broke it down here. I broke it down into like, all right, there's these like different cases, and then you have to think about how to handle each case. I don't know. I mean, look, again, maybe it's bullshit. Like, if someone actually gave me this problem in the real world, I would just try to shove it in a constraint solver. Because like, why should I be thinking like this? Constraint solver should be doing it, LLM should be doing it, all of that. But if you don't understand how to solve it, you're gonna struggle at the higher level thing. Like, I do think the tinygrad interview process is much better, where we're just literally asking you, can you code on tinygrad? But I'd be willing to bet, and we did it actually. When we did the programming challenge, we gave it to comma employees, and all the comma employees did well in it. Oh no, $250,000 in FANG. Wow, what am I gonna do? You're telling me I can ship better ads to people? Me? I can help connect people with products? Oh, My dream in life. The correlation between intelligence and success is much lower than hard work and success. Here's how that works. I heard, there's always a debate. It's like, do you have to be smart, do you have to work hard, or do you have to get lucky and to get success? And the answer is, you don't have to be the smartest, you don't have to be the hardest working, and you don't have to be the luckiest, but you gotta do pretty well on all three. You gotta be an 8 out of 10 on all three. Like, the people who are really successful in the world are not just smart. They are smart, they are hardworking, and they're lucky. You need good connections, not hard work. I completely disagree with that. That's a total bullshit take. That's a total bullshit take, and I hope all the people who like got jobs like that are just going to be weeded out. Sometimes luck means your dad was rich. That could be what luck means. Luck could be that you happen to stumble upon the right place at the right time, right? Like, there's definitely a component of luck, but there's also a component of luck in poker. And if I went to a room full of poker pros and played poker with them, I'd lose miserably. And my leaving that poker room, I'm not going to say, well, they got lucky. I'm going to say they understand how to control for luck and control for variance far better than I do, and that's why they beat me at poker. Is it possible to teach me Chinese? If someone was actually in Hong Kong and like spoke good Mandarin and like wants to like meet up for an hour a week and like try to teach me Mandarin, I'm down. How would I set my children up for success? I would use genetic selection technology to select for high IQ and avoid bad genetic abnormalities. Connections are basically useless. You don't need connections in today's world. You need skill. You need to be able to produce value for other people. And there's never been an easier time to demonstrate that, right? Like if you're like in the past and you're like in some like small farming town or something, you guys are all gonna make fun of me in the comments, be like, George, your LeetCode was wrong. Can you do this in a real way in 2025? To some extent, Gwern has a good Gwern has like a breakdown of like all the techniques you can use. You can do it to an extent, but you don't get that much selection power. So basically, like when a woman has their eggs extracted, you only get like maybe like 40, and then you fertilize them. You're gonna lose a bunch there. Maybe you're down to 20 or 30. And then like, so your selection power is like, let's say you have 16, right? That's 4 bits, right? So you get 2 to the 4th selection. And then I think 2 to the 4th selection, you can translate that to IQ points. It's like kind of straightforward. I don't know. There's a lot we don't know about that stuff yet either. Oh, cool. Send me an email. What height would I choose? I mean, yeah, I don't want him to be like short, but I don't think you got to be like some like mega tall person. I think that's one of there's a lot of things where like more continues to be better, and there's a lot of things where like as long as you're not in the bottom, as long as you like prevent the downside risk, you're pretty good. And I think that's true with height. Yeah, like I wouldn't want my like male kid to be 5'3", but according to Google, I'm 5'4", so you know, hey. Dangerous misinformation. TinyGrad on track for speed? Yes. Yes, we're on track for speed. Our MLPerf results are going to be nice. We're doing a lot better than last time. TikTok's making you stay at the bottom. But no, like really about the LeetCode stuff, like take a legitimate IQ test. I wish that we could be more honest about things like this in society. And like, yeah, if you get like 100 on the IQ test, you're not going to be a software engineer.
Like, let's just be real. I don't know. Would you rather someone lie to you? You got 120? Well, if you got 120, you're in the realm of where like you probably can do this if you grind hard enough at it. It's my IQ. I took an IQ test on a stream. Again, I don't think these things are like I'm not trying to like circle jerk about the number here, right? If you're if you're anywhere from like 120 to 160 or 120 plus, all these opportunities are open up to you. You got a 140, you're a dumbass? Well, you know, then that's all on you, man. That's all on you. That's even more stupid. No, like stop with the cope. Stop with the cope. I argue EQ is equally as important. Again, like, is IQ a perfect measurement? No, but that doesn't, like, everyone knows that. There's things that it perfectly correlates to, right? You got 119. If you want to be a software engineer at 119, you'll probably be fine. I'm just really saying, like, so knowing my code feels sad. Oh my god. See, this just turns into like, you guys aren't mature enough to have this conversation. In fact, like the whole like American society isn't mature enough to have this conversation. Yeah. But see, that's the other thing, right? Like beyond a certain point, it's not IQ. Notice how when I saw that LeetCode problem, like a part of my mind just couldn't stop. You know, I gotta do it. I gotta solve this. And if you don't have that, I'm not gonna like get on you about IQ. That's shit's like, but I am gonna get on you about that. If you don't have that sort of drive, if you don't have the sort of drive where it's like, oh my god, like I have to solve this problem, I really enjoy solving these type of problems, please leave the technology industry. Please leave. Nobody wants you here, okay? Like, get the fuck out. There's the door. Please leave. If you're not excited about doing this kind of stuff and you're just like the kind of person, I think you're a bad person. Please get the fuck out of technology. All right? If you're not here to make things that are great, if you're here to, oh, well, I just want to do mediocre work and get a FANG salary, get the fuck out. All right. That's a good thing to end this on. If you are excited about this shit, I mean, that's really what it is. That's really what it is more than anything else. If you're like, oh, LeetCode's such a grind, I just gotta grind LeetCode so I can get a comfortable salary, like, get out. Don't waste your time. You're wasting everybody's time, man. You're wasting your time, you're wasting their time, you're wasting the world's time. But if you see this stuff and you're like, damn, I love solving this shit. I love solving problems. I want to understand the universe. I want to understand everything. That is who we want in technology. All right? Is that clear? I hope I discouraged some people today. Everyone's big on encouraging people. There's way too much encouragement shit out there. There's got to be more discouragement shit. Because honestly, if you're gonna, Elon said this, look, if you're gonna listen to some discouragement shit and actually be discouraged, then get out. You should have never been here in the first place. But if you're gonna listen to that discouragement shit and be like, George Hotz a fucking asshole, I'm gonna show him, I'm gonna be the best software engineer in the world, I'm gonna grind LeetCode nonstop, I'm gonna transcend LeetCode, I'm gonna make a thing that solves all the LeetCodes for me. Congratulations, you just invented LLMs. Thank you for watching today's stream. We have about 30 years till your jobs will all be taken by AI, and none of this will matter. But until then, go to work, get things done, and create value for other people. Thank you for watching today's stream.